Hello, Rajiv sir.
Yes, sir, I can hear you.
Sir, actually, we will start just after 1 minute,
Yeah.
but usually up to 5 to 10 minutes they take for joining.
Okay.
So we will start now, but first 5 to 10 minutes you kindly go slow, then
Right.
you can. Okay, sir? They will
Okay.
normally manually join, they will take few minutes, but we have to start because after this again second session is there, no, sir?
Right. Okay.
So we have to. Anyway, sir. So I will request now officially it should be start. Rahul sir.
Thank you, sir.
Yeah.
Good evening to all the participants to the Faculty Development Program on Application of Communication, Signal Processing, and Robotics for Smart Cities. So welcome to the day for session 1. And today's lecture is Challenges of Achieving EMC Design for IoT Devices. And the esteemed expert is Dr. Rajiv Panigrahi. Before I request sir to commence the session, I would like to have a brief bio sketch of the esteemed expert. So Dr. Panigrihi is a senior tech lead at Next Intel India at Bangalore. His role involves primarily EMC modeling, measurement for package, board and system for network and telecom and products, before he is involved in AI edge product design and EMC validation. The author holds two patents, European and US, for low-cost wired communication at 1 Gbps speed using mobile design over 11 kV power line for rural internet distribution in India. Recently, he also involves in 5G RF front-end system design for RF1 and RF2 band and its validation for small cell V1 applications. The author has academically involved offered semester courses for industry professionals on fundamental of EMC for electronic product design to deployment at CCE ISC Bangalore in 2024 and 2025, and upcoming high-speed board design for semiconductor application on signal integrity in January to May 2026. With this brief bio sketch, I would now like to turn myself to Dr. Panegri to commence the session. Over to you, sir.
Thank you, Basu sir. No, thank you, Rahul. So I hope I am audible. So good evening, everyone. Let me share my screen and let's start the session. So just let me know if you can see my screen.
Yes, sir.
I
Yes,
will,
sir.
you can see it. Thank you. All right. Okay. Thank you, Department of Electronics Communication Engineering, BVIT Kolkata. Thank you, Dr. Deepak Kumar Naik, for reaching out, and he was really has put a lot of effort to reaching me, and we had a very good conversations and exchange, and certainly like us, there was apology from my side, like there was a delay for the responding his messages, but as somehow like we have concluded, and today we are gathering to discuss about challenges of achieving EMC design for 5G and IoT devices. So already we have, we got to know about me. Maybe we'll go quickly what exactly I do. So I actually I do an EMC modeling for Intel products, and especially like when I say the Intel products, I do a lot of work on the edge-based applications, or AI edge-based PC, especially for the industry applications. So there we do the EMC validations, and in today's topic we will go touch upon this: what is EMC and how it is related to electrical engineering, and what is the future in India. So especially we will talk about that. So apart from that, like we have established 5G setup for the TX compliance. So you might be heard about like the 5G bed where we are validating, and the government of India is very much curious on that. And today also we will discuss about like what is the status on India on 5G as well as the 6G. So this is what we do. Like once your board is ready, so we do validations and check like okay whether this board is 5G meeting the 5G requirement on. That's what the setup tells about, and this is the output and tells okay what how the board is. So apart from that, as I told, like I'm involved in this EMC modelings, validations. So this is nothing else like you make your electronic design. So we won't call it product unless until it didn't certify the EMC compliance certifications. So this is what the certification looks like. So this is one of the applications for edited emissions in the lab. So it is the lab is inside Intel, and we do a lot of certification tested that whether the product what we have made is qualifying the EMC requirement. So in case if you didn't find it, it's meeting requirements, and then we do some kind of near field measurement to find out why it is failed. So that's what it says here. So apart from that, I do a lot of modeling. So what we see here, so I mean, let's say like you find it, your board is not working or your board is not meeting the licensing. So how do you find out? So we do a lot of modeling also. So through the modeling, it saves a lot of time. And before going to the lab, maybe we'll go more discuss on that EMC, on that what is EMC, what is licensing, what is rejected emissions, near field measurement, all those things we will touch upon. For especially like as the topic says that, okay, what is the challenges? So I'll go quickly on this. So this is more about me, like what we were working on. So recently I moved on the server design as well. So you might be heard about that Intel and NVIDIA has a collaboration. So this is basically we were working on the server design part, where I'm mainly involved for the high-speed designs, where the signal integrity comes in. So apart from signal integrity, we do this EMC validation for the server design application as well. So as I told, like, so through the simulation, so you can actually check like, okay, how's your board, behaving in case if it fails. So it will give you, kind of a signature saying that, yeah, you need to modify certain designs. So that's crux in the, in today's session as well, like how simulations in today's world, how this RFEDA tools helps actually to making your product more robust and, cost effective and launching to the market before the time. Because most of the time, what happens, like functionally, you will be very right. But the moment you go for a certifications, we will discuss about that, what is called certification. But that is a very much very much needed for a product. I mean, any electronic design to be called as a product and launched to the product in the market. So that's all about the quick about this EMC measurement and the simulations. So as we are told, like, okay, I'm quite involved in the academy recently. So last 2 years, actually, I'm offering a course at ISC Bangalore. So under the proficiency course, so where we discuss about this fundamental of EMC for the professionals. So where we see like, okay, how from the scratch actually you design, from the scratch, how you introduce this EMC at the beginning itself, so that it saves time as well as a cost, and also it gives you a good signature before going to the certifications. So I have taken from this course actually one common slides. I like wherever we go, so we take I take these slides and I just discuss about this. So if you see this, if you look at like I just highlighted, this is last year in August 8. So there was a news in the this is I have taken from from Hindu. So so it's here about like the headline wise, like how are hackers using AI and SDMI cables to steal your passwords, right? So it's quite interesting. So we are engineers. So when we read such things on a national, forums, like where it did the a national paper discuss about the engineering stuff. So where it says like, it is something is related to cybersecurity, as well as like somebody using the AI. So we got some few words that is called AI, the buzzword. Through the AI, they can actually steal your passwords. Even you might be seeing like a few of the passwords are weak or a few of the password got leaked. I mean, such news came, but this is very much big in the lab, in the front page, saying that so hackers can actually use AI and through the SDMI cable. So if you see SDMI cable, which is quite used on your all monitors, I mean, if you are connecting your any kind of your system to your in display through the cable, either by USB-C or Type-C cable or your SDMI cable or a DP cable. So one of them is like SDMI cable. Through that, actually, they can take your passwords. So today we will be seeing from from that perspective, right? So before to that, I just let me introduce my favorite part is the EMC will. So when we say EMC, it's a electromagnetic compatibility, right? So in the electromagnetic compatibility will, so we just see like for any given electronic design, we try to reach out these three common factors such a way that so it will meet your requirements. So if you see, look at this, that's actually created challenges. So whenever you go challenges for achieving this EMC design for 5G and IoT devices. So if you see here, the three factors, nothing called cost, quality, and speed, right? It means now you are being engineer. I think most of the engineers do their startups, and as second year onwards. So it's my duty, like to explain, like okay, let's involve, like whenever you are designing, going for an hardware design. So make sure that you also go through the same phase, like introducing the EMC things at the beginning of your design, so that it will reach to the market with sooner, with the with the best quality and with a low cost. So that's a EMC will. So if you want to make your design robust, cost effective, and sooner to the market, so you have to follow this EMC will. So in this, if you see, there are two marks are moving around. So we cannot actually compromise the third one. So what it says, like at every moment, right, you have to meet this all three requirement without compromising any other, the third part, right? So before moving to the today's session, I really thanks to the Google search and the snapping tool. I think we mostly have used here. So most of the sources I have taken from the Google search, and I use the snapping tool extensively to just to involve most of the audience into these sessions. Yeah, let's move to the IoT or 5G devices. So this is the latest news. I just searched what is the 5G market in India 2025. So I think you might be knowing this Mobile Congress 2012 recently happened last week, and these are the highlights. So if you look at this, Ericsson demonstrates 5G and AI innovations at India Mobile Congress 2025. India's Jio T-Mobile launched 5G SA roaming this year report. India surpassed 365 million 5G users, drives data search in 2025. And Ericsson India Mobile Congress showcasing 5G innovations that power India digitalization and journey. So if you look at, like, if I just went to very detailed from this first news. So this is what Ericsson actually claimed. Like they actually demonstrated. So these 5 things. So you can actually reach out. There's the same news. So if you look at this is a 5G enabled grain ATM Anamurti. Steto ECG. So you can go through the descriptions. So I think due to the short of time, I don't want to go very detailed, but it's very clearly mentioned, like what is the area, what they have actually demonstrated. So when they say it is demonstrated, means the product is ready, right? So when we'll discuss, in this session, like I'll tell you, like, okay, what is a product and why I'm talking about electronic design, right? So how this electronic design can be converted to product, right? So when I say it's demonstrated, means the product is ready. So that's why they have demonstrated the 5G enabled grain ATM Anapurti, state ECG, automated rail car inspection using robotics and AI, fixed wireless access FWA, so which is like which gives a higher like speed wirelessly, especially in rural areas. So it is one of my topic, like where we have patented it, which is one of the low cost applications, and in the various states of India we have actually implemented. Then the last one is a retain right to the future. So immerse air-powered demo showcasing 5G connectivity for the commuters. So these are the very recent things. So I've just take a snap from Google search. So where I just put like 5G market in India. So if you go to the this Indian market, so Indian Internet of Things market. So what says, like maybe in 2019 we are maybe looking at, currently we are at $32.9 billion, right? But what is our 10 years, like if you look at our PM also says about 2047 vision. So if you look at 2035 itself, we are reaching out almost threefold, 3 to 4-fold of the target. It's 104.7 billion, right? So why are we talking about Internet of Things at India? Because if you look at, so previously we were actually same for our the populations, but if you look at from the engineering and point of view or the market point of view, we are the best, best case to be implemented because we have the users. That's what it says here. So we have so many users we have, so that we can test all of our product into the market. Means we can reach out every user very sooner and you can test like how it performs as well. So that's why India is one of the best place to test your design. So if you look at here, I mean, by 2035, so the target is 114.5 USD billion. So that tells about like where we are. So it means that we are in the race to challenge in the or the compete in the market. Moving back, so when we say this IoT connectivity, so I just give a little brief about IoT. So it's the Internet of Things, and it is somehow it is connected also to the 5G. So when we say 5G, so it tells about the speed. I mean, in a generic term, but 5G, AI, IoT, all are interconnected. So that's what this is from the 21st August 2025, where the PM says like India lead to the next wave of 5G, AI, and IoT. Obviously, because we have the base, we have the engineers, and we have the test case. I mean, if you want to make a design and reach out to the 1 million case studies to see the robustness of your design, India is the best place. I mean, India or China is the best place because you can reach every user sooner and you can test all your case, right? So if you go for the IoT connectivity, so these are the very five things. Usually we define LP1, cellular, Bluetooth, Wi-Fi, Zigbee, or the RFID. So based on this, we try to segregate your IoT devices. But if you look the continuation from the previous slides, so the growth trends like this is all about number of devices actually now currently we are connected. So in 2022, around 13.1 billion connected IoT devices, right? And these all data we have taken from AutoBits. So you can also reach out. This one I just took a snap from there. So if you look at 2030, almost globally will be 40 billion devices will be connected. All will be connected through these electromagnetic waves, right? So now if you go segregate the sector wise, so if you see any electronics, so if you segregate that, then consumer electronics will be 60%. Right. We will go in detail. What is consumer electronics? What is industrial applications? What is healthcare, smart cities or infrastructures and logistics supply chain? So these are the lower in the number. But if you look at the consumer electronics, so your phone comes under consumer electronics, your laptop comes under consumer electronics, but the similar thing can be converted in the edge device where we can put more throttle and more stress to make it for the industrial application. That will come under industrial manufacturing. Healthcare, anyway, we know like now most of these devices are actually they are making IoT devices are actually used for the healthcare applications. And anyway, we have I think last 5-10 years we are working on the smart cities and the infrastructures. Although its numbers are very small, but still, I think sooner we'll be seeing the cameras across all, on the rural part of India, which might be looks like, okay, not possible. We may not have an infrastructure, maybe some just to show off. No, it's not going to happen. Today, the world is in a different direction, especially India is in different directions. Everybody wanted to reach out and test their test beds, right? Because we have the users. So it is quite possible if you look at, if you remember, like in 2010 or maybe before that. So there's how the internet cost you, right? So even for a 1 GB, you have to pay 100 rupees now. But now if you look at like, I probably like, per month, even if you take for a 3 months or any of the SIMs, right? Like they give, per day 1.5 GB free. So that's a change actually we are. I mean, it's not that it became more cheaper, it's because the users are more. So there is a competition there, they need to reach out. And probably like, at the same time, still we are at the backstage because this wireless or wired technology has not reached every corner of the world, right? Or every corner of the rural part of India. So that's what the contribution we were looking at, like how to reach every corner so that the information cannot be stopped because of the connectivity, right? So IoT is the one of the answers, like where actually you can actually meet those requirements. Right. So this is little brief about IoT and the 5G. Maybe over the time we'll go more detail, but now a little I'll move to from the electronic design perspective. So as I told that we are discussing, I mean, I've just taken one snap where in the Hindu newspaper, they were talking about how the hackers are actually using AI and SDMI cables to steal your passwords. So we'll just touch upon on that. So it's going to be very interesting. So one thing I can assure you, so in today's session, we will talk about the good part of Indian politics. So probably we are come across different type of negativity about Indian politics, but I'll show you like yes, we are actually at the good time where the Indian politics is involved on engineering stuff. Let's move on. So this is what happens in August 8, 2024. This news came. How are the hackers using AI and SDMI cables to steal your passwords? So this is what my observation. So I started looking at further. So this is in happens. I'm just going with the timeline chronology. So if you look at, so this news came in 8 August, and following that on the 7th December, there is another news came, probably the another newspaper. It's a again national newspaper where it says like no evidence that hackers are using SDMI cable to steal passwords. So this is actually Ministry of IT in Rajya Sabha. So it means like something is cooked up, something is actually also garnished and preferably like given to everyone. So we probably I was not aware of. So I digged out like what's happening, right? So somebody asked questions and somebody has answered it in the Rajya Sabha from the Ministry of IT. So I just digged down this one. So going into the government side. So if you look at here, so from where it actually starts. So this is on 6 December. So after this, it is actually posted in 7 December on the national newspaper. So how it starts now here. So on 8 August, it starts like, okay, SDMA cables actually steal your password, raised in the common the public arena. And this question was asked the Honorable Minister, so to Ministry of Electronics and Information Technology, saying that whether the government is aware of fact that hackers are using AI and SDMI cables to steal user passwords, right? So this is asked by the Honorable Minister. So then it is answered by the meeting. So you can see Sri Jitin Prasad actually answered it, right? So it is quite, you can reach out this site and it is really actually answered, and this PDF is available on the Google. So you can also download, you can go through. So what the government actually answered, the government is aware of various cybersecurity threats, includes those involving artificial intelligence and other technology. However, there is no evidence to suggest that hackers are specifically using high definitions multimedia interface, that's called SDMI cables, for stealing user passwords, right? So this happens on the public arena, right? So we are engineers, right? So we need to know why and how suddenly it has all started. So this is what the chronology starts. But let's go a little wind to the before. So this happens in 8 August 2024. So we are from the science. So let's look at what happens in the articles like on the science journals. So this is the journal actually submitted called, on the topic called Deep Tempest. So this is called, in this article, what it's mentioned, using deep learning to eavesdrop on SDMA from its unintended electromagnetic emanations, which is submitted on 12th July 24. So if you look at once it, this article was access to the public. So based on that, this question was raised and it reached out the ministry, and the ministry have answered. And the next day it has published saying no evidence that hackers are using SDMI cables to steal passwords, right? So if you look at here, this I have taken again this snap. This is actually the main source of this whole chronology. So this is again, you don't require any kind of access to this particular one. You just search Deep Tempest on Google, so it is pop up with a PDF like you can go through. So I'll give you very quickly on this. So what it says like, so this is a monitor, right? And this is a CPU which is connected through this HDMI cable, and this is what actually the user actually showing a picture, right? So through this HDMI cable and this AI, so antenna and SDR, so the software-defined radio, so you can actually do these grades GR Tempest. It's kind of an AI algorithm, and using a convolution neural network, you can actually retrieve without reaching out knowingly to the user, and you can reach out, you can get all the data from the users. So that's what it tells about. So that's why all this questions and answer actually happen. So now the question is like, you are an engineer, right? We cannot say yes or no based on just somebody said it, right? We are engineers, means we are runs by the data. So let's look out the data. Like why an HDMI cable? Is it possible through HDMI cable to radiate or get your data using the AI algorithm? So if you go inside, so let's first find out what is an HDMI cable, right? So this is what the HDMI cable looks like. Probably now you might have understand, okay, this is what they are talking about. So using this cable, it is quite possible to get your data, steal your passwords. That's what the headline, right? Now, let's go what the HDMI cables is capable of. Like if you look at, so this is the speed we are talking about. So on the y-axis, we see from 1 Gbps to 12 Gbps. On x-axis, it is a different type of versions of your, different type of high-speed IO interfaces. Like on them, so your SDMI 1.4, SDMI 2.0, and SDMI 2.1, right? Even last 1 month before, actually SDMI 2.2 also came. So now if you look at SDMI 2 1.4, the initial versions of the interface, it is capable of 3.4 Gbps per lane. So now, I mean, do not look about, why it is 3.4, where it is come. It is just a comparison with the different versions, right? So SDMI 1.4 is capable of 3.4 Gbps speed, while SDMI 2.0 is 6 Gbps and SDMI 2.1 is 12 Gbps. Now, if you look at here, now, I mean, the total maximum data rate, SDMI 2.0 can go up to 18 Gbps. Now, if you move to SDMI 2.1, it is 48 Gbps. I mean, we are just triple the speed, right? But if you look at the number of lanes is here on SDMI 2.0, what is 3 data lanes and with 1 clock lane, while you're on SDMI 2.1, the 4 data lane with 0 clock lanes. Okay, so I'll just put a note here, like when you have a clock lane, it has, I mean, the RF wave has the intention to start radiating if your cable is incapable. I will talk about what is incapable of a cable, but when you have a clock lane, it has a tendency to start radiating. So that's the fundamental of, involving this clock. So that's the reason why if you are using SDMI 2.1 versions of cable, then you may not see any kind of radiation coming out of it because there is no clocks are there. Okay, that's the basic difference. I just put put information like, okay, why SDMI 2.1 will be safer than SDMI 2.0. But the question comes like, okay, why this SDMI 1.4 or SDMI 2.0 is radiating, why SDMI 2.1 is non-radiating? So what makes you different? Before to that, so I will ask anyone, maybe just let me know how many buy SDMI cables from the local shops, and what did you ask to the local shops, right? So anyone, what is the what is the specs you will tell? I mean, you are an engineer, so how did you actually define SDMA cable to the shopkeeper? So I keep one note: the shopkeeper may not know anything on the technical side. So based on written on the cover, he just tells you. But I just ask you, like, when you want an SDMI cable, so what did you actually look for? What is the specs you try to mention? Probably I'll go quickly because I have a short time. We have a lot of things to cover, but this is very curious one. So what we say, give me a 1 meter cable. That's it. We need a SDMA cable. We don't know, like, okay, whether it's 1.4 or 2.0 or 2.1. Nobody asked about that. We just ask, give me 1 meter cable so that it connects my, laptop to my monitor, or a TV to my monitor, or I want to extend it. Or if you want longer, then go for 3 meter. But when you go for SDMI 2.1, I mean, now technical side, so the shopkeeper says, no, you cannot take SDMI 2.1 3 meter because it won't work. I mean, he tells you, it is what informed to him, like, do not take long cables for the high speed lines, because when you have long cables for the high speed, I mean, advanced one, your the 48 Gbps cannot be delivered. So that's why you have to take a short cable. That's what the informed to the shopkeeper. That's why they say, if you are taking the better version, so take a short one. So it is always advisable to take a short cable for any of the applications so that you can actually deliver the maximum speed. But one thing we are missing, that how do you know that this cable SDMI is incapable of radiating it? Because we are not buying antenna for our device. We are buying a cable or a connector between your device to the monitor display, right? So for go in detail, so this is what the inside cable looks like, right? So if you see here, what you see, this is the connected part, and this is internal, which is always covered, right? So this is nothing else, your shielding. Maybe you can say braid cable. So if you open anything, like you will be seeing, even if a coaxial cable, if you take, so you'll find this braided cable. So from the functionality point of view, it has actually, its existence itself is enough, right? But if you really wanted to check, like, let's not radiate my cable, means let's not make my SDMA cable as an antenna, then you need a good braid. I mean, you need a good ground shielding. So this ground, I mean, whatever you metal things you are seeing, that's actually used for ground shielding. So this is the ground shielding for your device so that it should not radiate, especially if you are using SDMA 1.4 or SDMA 2.0. So that's the reason why you need a good cable with a good braid. I mean, good braided cable. Well, okay, how do you actually conclude it? So what it says, so this actually, this data, whatever like I have taken, so these snaps I have taken from here, but this data actually from my lab, I have just tested it because I just follow the chronology, right? So what I see here, so on my left side, so this is a little more technical on the RF side. So those are from the RF side, maybe probably will be aware of, but those are not from the RF side. Just I want to say that if you have a your this graph across, this is x-axis, which is a frequency. So across the frequency, if this graph is closer to zero, it's a bad one. If it is away from the zero, it's a good one. So this phenomena we call as a coupling. So these couplings, so what we see here, so those cables which has a very good braided, I mean, the number of layers of your metal shielding is good. So you are much away from the zero line across this frequency. It means from this frequency to till 1 gigahertz, you won't radiate, right? While the other one and the same cable, I mean, as I told, like if you go to a shopkeeper, he won't tell you like, okay, how's the braided cable? He will tell like which is cheaper. Or maybe you will ask like, okay, I want a 1 meter cable, which is the best for me. So he will give you something, tells like it's a 400 rupees, I have another 200 rupees. You will choose 200 rupees to save the cost, right? But if you ask him like, okay, how's the braided cable in between them, he has no idea. But you have to choose in such a way that it should have the strong I mean, weaker coupling. I mean, away from the zero. You shouldn't choose this particular one, which actually which tells or give a signature like it is capable of actually radiating. So this is what it looks like when you, if you compare both sides. So you see here, this is the connector, and internally you have all those data lens are there, and it is actually covered by multi-layer of ground shieldings, right? While if you look at the other, the poor one, right? So you have a very poor shielding. So the same thing here as well, right? So there is a no shielding here at all. If you compare these two, you see there is a copper or something is actually wrapping around it. So it's nothing else as a copper, copper film. So which actually wraps around it and gives a good, shielding from this RF couplings. While here, they actually forgot it, right? So this cable is actually, very, I mean, poorly shielded. So this cable is capable of, radiating. How do you confirm it? Because it's a visual inspections, right? So there are certain, instruments are there. I mean, if you go to a spectral analyzer or in the spectral analyzer actually across the frequency. So this is again from this lab. So what we do, we call this near field probe. So what we in the previous slide, you see these four, I mean, the graphs are from the four cable. So the blue lines is the noise floor from the spectrum analyzer, while the other three are actually the same I mean, functionally they are same, but their behavior on the coupling side is very different. So what we see here, which are actually post shielded, it is an orange color, while which are actually better one is in the black color. So the other one actually comes in between, and somewhere actually it is bad, somewhere it is good. So it is all about orange versus the black, right? So we have to certainly ignore this particular part. I mean, the orange one, because it is actually capable of radiating from your system. So we have to, should not buy this particular SDMA cable. At the same time, we can go for, the black one. So the question comes like, so how come is one SDMA cable having a different electrical behavior? This is what is talking about on the national base. One raises the question based on the submission. Another says the answer, it is not necessary. All the HDMI cables actually, start radiating. So it all depends like how is your cable. If your cable is well shielded, metally well shielded, all wrapped around it, so certainly you are coming under the green board. If your cable is poorly shielded, you comes under this orange board. So the answer is dual. Yes, it is capable of, because as the submission says, if from the HDMI cable, if it is capable of radiating, you could be using some of this convolution neural network to retrieve the data. So if you can retrieve the data, certainly you can actually steal the passwords. That's what it talks about. At the same time, if it is properly shielded, and technically, if you look at those coupling behavior across the frequency, then you actually lies on the first board. The green board, where actually tells like, yes, it is not impossible to get your data. That's what these two are talking about. So you have to look at in terms of engineering thoughts, right? How it is possible or how it is impossible. So the answer lies like what you're actually looking at. So you have to choose the proper HDMI cable. That's why the EMC becomes very interesting. So here they introduce like why you need to understand EMC. Especially if you are doing in hardware design, in bracket if you are design electronic design. So if you do you are not aware of your hardware design, EMC, so certainly you will be trapped under a well where actually it takes a lot of time and cost to come out from that well. So that's we called EMC well instead of the wheel. So if you introduce EMC wheel at the beginning, so you can save your cost, save your time, and you can make your design robust. So I hope this is very interesting. Now, the whatever you understood in the chronology, behind that there is another reason behind it. The reason is regulatory red. So anyone, any idea what is red? You can use your chat GPT as well, or Google search will be sufficient. Let's see what your Google search says. Maybe I'll go first. So regulatory red is nothing else. It's a kind of a regulatory for all electronic design, which is introduced and mandatory from 1st August 2025. That's why I said now Indian politics is very interesting. Now government of India or the people of India wanted to reach out the world. So it means you are designing a product and wanted to reach out European Union. You want to sell out your product to European Union. It means you have to follow radio equipment directives. So that's called RED, regulatory RED. So which is actually mandatory from 1st August 2025. So the whole story starts from 2014. So actually it was introduced. It is like regularized by 2022, but later on it has actually become you can see the chronology again. So 22, it became, European published delegated regulation in 2022-30 European Union. It was enforcing the compliance required to read, RED regulatory. So it is actually planned for 1st August 2024. But later it was extended, so 1st August 2025, and it became a mandatory from 1st August 2025 that every electronic design which has the radio equipments needs to follow this RED regulatory. So that's the reason why the whole chronology actually start talking about it. It came in the national newspaper, and they were talking actually, okay, we need to follow all this, the compliance. So let's go what is RED, right? So it's a very quick one. I won't go very detailed in this. So today we are discussing about EMC. So where we'll talk about electromagnetic compatibility. So without introducing this electromagnetic compatibility, just to tell this story, just giving a little brief about this, this RED and all this chronology, right? So when you make any kind of electronic design and you have a plan to sell out outside India, right? Then you have to follow this regulatory authority. So for US, it is FCC. For Canada, ICD. Japan, MIC. South Korea, RRA. China, CNCA. Or if you go for European, it is CE. So turn your, go back to your any electronic product right now, and you can actually go check actually. There will be some marks would be there, right? So CE, FCC, or CC. So these are nothing else. That particular product can be sold out at that region. So this symbol tells like the product is belongs to can be sold in this particular region, right? So as we discussed in the beginning, right, there are be different type of electronic design for different applications, right? So you are seeing a display monitor on your phone, you are seeing a display monitor on the advanced or the advanced car, right? So both are the same monitors, but those, the product functionality is same. You have a touch screen, you can do a phone call, you can see a GPS, everything remains same, but the application, so the place of the placement of this product design is different. So your product comes under consumer electronics, and the display which is actually showing on the inside the your car is comes under automotive, right? So this is a different, same functionality but different, locations. Like one it's on the consumer side, so under consumer electronics, while the phone comes under automotive. So here the compliance is introduced for a particular electronic design. There will be a different compliance, right, based on there where actually it is placed. When it is comes under consumer electronics, you will go this FCC or CISPR 16, while when you are going for like automotive, you will go CISPR 25. Same functionality, but different placement. So the compliance is different, right? For automotive, you'll go CISPR 25 regulatory, while for let's say phone or a laptop, certain for consumer applications, consumer electronics, you'll go FCC class A and class B. So based on your where you are actually keeping it. For if you are using a class B, if you are using a laptop or mobile phone, it will be class B. If you are using it for industrial application, it will be class A. So likewise, you have a military, you have medical, space. There are the different type of applications are there. So this is what it talks about. So again, I have took a snap from the Google search. This is all about this RED, which is introduced on the European Union regulations. So what it says here, so what it says, these are the steps you need to fill out before sending your product to the European Union. So here, if you look at, this is a note which is mandatory from 1st August 2025. If you answer no to any items, prioritize addressing these gaps to ensure readiness before 1st August 2025. It means like what it says, like if you are failed to meet all the step 1 to still step 6, you cannot sell out your product. Okay, let's say you have spent plenty of time on your R&D product, making a functional demo, prototyping, everything, but you forgot to introduce EMC at the beginning. At the end, you just reminded and you start working on it, and you are failed to meet it. It means that you cannot sell it unless you are not, you are saying everywhere yes. Okay, so this is what about RED. So this is introduced for European Union. So similarly, like it's for there for China, Japan, or US, or the different regions. So whenever you make an electronic product design, so two things you have to keep in mind: where you are actually placing it and where you are trying to selling it. Same product, but different requirement would be there. So you have to follow accordingly, get a report, and send to your custom saying that yes, I have a product, I have a certification. Now you can actually send it out. If you fail to do that at the custom office, even if you bribe it, they cannot send it. We will see a case like, okay, in case if you are not meeting these compliance requirement, what happens, right? So before that, let me introduce 5G device or the smart device, right? So I think we are in a technology arena where everything is like wireless, and you get your data or sensing it within some nanoseconds, right? So these are the very quicker one. So I think we have not forgot this COVID-19. So during COVID-19, without touching anything, if you want to buy anything, like how you will do it. So this is Sensormatic Solutions, which is helping stores open safely during COVID-19 by integrating their solution into existing store infrastructure and cameras, right? So you don't need any human interface here. So without doing that, also you can purchase it. Now that's like on the retail side. Now if you go for 5G or edge computing, so a remote 4K video camera connect to the Fox Sports network over a 5G link using a spectrum provided by AT&T. Ericsson 28 gigahertz radio and antenna are located to the tower seen in the distance, right? So it's like a fascinating technology. Now, this is my favorite part. So if you look at, I think, I don't know, like anyone doesn't know him. So if you look at, like, this is one of the quickest stump out in the cricket world, right? You can see the reaction time. So here the important part is your device is capable of sending you 4K video without any latency. That's your 5G and edge computing, right? Because of that, it is quite easy to identify the foot actually away from the crease, right? And see the reaction time. That's nothing else your latency. See the quality of your picture. That's nothing else your 4K. So these two all possible because of your edge computing device. So that way, let me introduce what is an edge computing, and especially I'm working on that area, right? So what you see in edge computing, there is a lot of internal interfaces are here. What you see as standing are, I mean, those are not from the RF. So this is nothing else your Wi-Fi network with all your antennas around. So you see, these are the interface. So one of them, what we earlier we discussed about HDMI. Likewise, you have the VGA and sometimes the DP, sometimes your Type C. So different type of applications. Or if you want to inject, high speed information through the storage device, you have the USB, USB 2 or USB 3, right? So now if you look at from the application side, Netflix, YouTube, live sports, all are using this edge computing. So that's what we get, the quality over the quantity, right? So now let's clear out what is inside your edge computing devices, right? So this is your source and what this is look like. So if you tear out what you see in the top black one with some ridges, so that's from the mechanical engineer side. So your product or your design actually works at the maximum efficiency. It become hits up. So somebody has to take those hits. That's nothing called the hit chamber, right? So so if you remove that, you see inside, there will be two sides. I think we all introduced this, semiconductor process initiations in India. So sooner we will make these chips, right? So on the front side, top side, if you look at, so this is your processor, and all your corners will be, will be connectors. So these will be called, connectors. Through the cable, it can be DP or USB or HDMI. It reach out to the other side, like maybe to camera, to display, or to maybe a storage device. So that's your connected to the outer world through these connectors, right? But inside, what you see is a microprocessor. But this size, what you're seeing, this is not limited. So you see in the different applications. You might be knowing this. Apple has a small mini SBC, single board computer. So likewise, that is nothing else, the mini ITX form factor. So this is the different standards. What we see, standard ATX, micro ATX, mini ITX, and nano ITX, and pico ITX. So this is how it looks like. So most of those single small computers are actually under mini ITX form factor. So it says like in a small size PCB, you are actually have so many interfaces, right? So that's a challenge actually. So with a smaller size, you have to place so many interfaces on the top. But if you look at, this is a PCB, have a significantly or definite thickness, either 0.8 mm or 1.6 mm. That's a industry standard. So when you say like 0.8 and 1.6 mm thick, but having so many interfaces, it means you are using a multi-layer PCB. Maybe sooner I will start multi-layer PCB. So this is what the 1.6 mm or 0.8 mm PCB looks like. You have so many layers just to hold these many interfaces. But if you look at the floor plan of your interface, so this is how, if you go for in a generic manner, so this is how it looks like. You have so many interface for the digital circuits and analog circuits. To power it on, you need power circuits, and to work on the system side, you need some low frequency circuits. To reach out to the outer world, you need connectors. So that's a basic, a floor plan for any given system. So you make any small or the big one. So this is how it looks like. Maybe you have analog circuits only, or you may have a digital circuit, or you have a combined one. You need a power circuits. You have to run it, right? So that's and to run the system, you need low frequency circuits. To reach out the outer world, you need connectors. If you are not by cable, you have to do wireless. That comes under Wi-Fi or Bluetooth, right? But so to assemble all these interface, you need a multi-layer PCB. Now coming down to the EMC. So in the EMC, I think I showed you like, okay, we do some kind of near field measurement. So basically what we do by this near field probe, we just try to find out where you see the hotspots, right? So these are the two of my students' work. So from the NIT Hamirpur. So these are two things we have implemented and to improvise your EMC behavior. So with this methodology, I mean the near field probe, you can find out these hotspots, right? So basically what we do for a given system, we just try to see whether you see any kind of radiation through the cable or from the system. So that's what we are trying to do. So that's we call using a network, spectrum analyzer and a near field probe, we can find out this hotspot saying that which is actually source of your emissions. Right. So that's a very little brief about near field, emission. Let me go to a, challenging part. So what if like, if I don't do EMC, what happens? This is what happens. So this is very much, known product. So if you look at, iPhone 12, so again, European Union. So European Union considered as to be one of the stringent market to, pull over inside. Okay, because they are strict in terms of if you didn't qualify your EMC certifications. So the France halts iPhone 12 sales over radiation levels. So this particular we know iPhone. So this particular one actually exceeding the limit. So that's why they stopped it. So you see, just imagine, France has ordered Apple to stop selling the iPhone 12 for emitting too much electromagnetic radiations. It means that you have made 1 million, products, and just because it couldn't meet their requirement, they said you cannot sell it. Right? That's a huge loss. So similarly, like these are the few more. I mean, in order to keep, just to maintain the regulatory. So you might be seeing this is the older one. This is 23, and the 21. There is another one came. The Apple shares list of products to keep safe distance away from pacemakers. So what we understood from here, like when you couldn't meet the certification from the EMC, electromagnetic compatibility, certainly it impacts you, the user itself. So if the user is using this pacemaker and your product is not qualified, it can interfere your functionality of your pacemaker. When you say interfere, it's not intentional, it is unintentional. It means it can stop your pacemaker. So that's a hazard. So there are so many other, history also there. So if you look at this is one of the things had happens. So it is the older one. So, but at that time, if you like $60,000 actually for a particular product, if you look at the product is nothing else hair dryer, right? So in 1992, Hartman Pro 1600 hair dryer actually gave a penalty of $60,000, and probably they are not meeting the EMC requirement. Right, so that's actually hazardness. Like it can interfere, it can actually keep your system off. Right, so this is one more actually. This is the human hazard. So because of some of these EMC requirement comes under ESD. We'll talk about this electrostatic design. So so ESC. Because it failed to ESC, then it gets exploded. So New York to Paris. So over the ocean shortly after takes off, right? So these are the from the history where actually EMC is must now. So if you are making a product design, have a plan for a startup. Let's understand what is engineering needs it. So it's not about always the prototype. Also, you should have an idea. Maybe we'll talk about how it makes you, right? So if you have an idea to launch your product, keep EMC intact at the beginning so that you can save your time, cost, and robustness. So we talked about this EMC well. So what it means actually. So what it says, the quality and low cost at low speed. I mean, let's say if you want to do compromise, one of them, what happens, right? So you wanted to make equality with a low cost, but having a low speed. So why start if it never finishes? So if your timeline is after 3, 4 years, by that time you launch your product, probably somebody have already launched it, used it. Maybe you are be nowhere in the history, right? So this is what happens if you compromise the speed. Okay, what if like if you go for low cost speed without the quality, the robustness? Why start if the result is not useful, right? If it's delicate and maybe within 6 months, if somebody is broken, then why to make it that one? So that's the second one. The third one is, okay, let's go let's go with quality and speed with a high cost, right? Certain things, I mean, I don't want to pull out like certain devices, I mean, engineers has made with the best quality, maybe sooner to the market, but the cost is too high, right? So let's settle within our budget. So it means that although these three are the requirement, you have these ticks are here, but you cannot compromise it. So that's why EMC will tells like you have to make low cost, high quality sooner to the market if you introduce this EMC requirement. So let me segregate the EMC. So it's a electromagnetic compatibility, which includes radiated emissions, radiated susceptibility, transient immunity, electrostatic discharge, and bulk current injections. It depends where actually you're sitting. So you might be seeing here a car. So this specifically talks about automotive. Likewise, you have a different electronic design. So your whatever you are seeing, the bulk current injection might not be there, but certain other additional tests will be there. But before going to those sections, let me introduce what is emission and susceptibility. So what do you mean by radiated emissions or radiated susceptibility? Maybe you go more detail. So under EMI and EMC, again, electromagnetic interference or electromagnetic compatibility. So under compatibility, you have radiated emissions and the conductor emission. Under immunity, you have conductor immunity and radiated immunity. So what is emission and what is immunity? It tells, so there's two different houses. One tells I should not interfere with my neighbor. The second tells the neighbor should not interfere with me. That's your emission and immunity. And what is this radiated and conducted? One is with wireless, another is with wire. So that's it. So you have four category. One is, I mean, two neighbors, and so you should not disturb your neighbor, and you should not get disturbed by the neighbor. That's your emission and immunity. And so you should not disturb neither by wire nor by wireless. That is radiated and conducted. That's a 4. Plus the fifth one is the ESD. So electrostatic discharge. So human body carries charge, right? So unless until it didn't discharge, so to the ground, it can discharge to your electronic system. So by touching, you might be seeing some time, especially at the summertime. So when you have a very dry wind, you may get some sparks on your fingertips. So that's nothing else electrostatic discharge. If your system is incapable of this electrostatic discharge, so probably it can actually burn out or can buzz off or totally collapse your electronic system. So that's electrostatic discharge. So when you are making your design, when I say robustness is not about how we are making strong by putting more or by pouring more steel. It's all about electronically how you are making this robust, this ESD. And if you go a little more on this, the definition by, from the engineering point of view, so what it says, emissions not to interfere to other devices in its environment. Because when you are radiating, so certainly it has a certain power only. So within that environment, it should not interfere. So the same thing, the same definition, do not get disturbed by your neighbors, not being upset by other devices. Again, in its environment. Sometimes what happens, you can actually disturb by yourself. Like in a home, you may have a siblings, right? How they fight and get disturbed by each other. So that's called, radio frequency interference. So because of fight between the siblings, so what happens? The output, the efficiency comes down. I mean, any work was given to them, they won't do it because the interference between them. So that's radio frequency interference, and this is what not to be destroyed or malfunctioning when touched by human. That's a electrostatic discharge. So this is the fundamental for any electronic design. So when you are planning for making a electronic design, certainly you have to follow all those. And if you want to improve it, so you have to. There are a few kind of thumb rules. You have to make sure that having a good grounding, good shielding, good filtering devices to filter all this noise, and make sure whatever you have, choose the cables, especially HDMI cables. So cables, connector, gaskets, there are some other terms which will be used are helpful for your making your design robust. So going little more detail, so any products, that's why I say equipment under test, UT. So when you are an engineer and making a design, so we will call as a UT, not product. Product only for the user or the customer, right? So we are making, if there is some questions, let me answer. Okay. So let me, in between, if you couldn't want to understand or you want to ping questions, please, come out and, throw it. So what do we see here? So it is any given black box which called under equipment under test. It need to qualify what we discussed: rated immunity, rated emissions, conductor immunity, conductor emissions, EST, and there are a few others one, right? So this is the fundamental EMC and EMI, but I mean by definition. But if you look at like it's a kind of you are making a system or the capability of a system to perform as designed in the intended electromagnetic environment. That's the basic definition. What you are making, so if you expand this electromagnetic compatibility, it is compatible within its environment, not disturbing others. Interference, it's not getting, or immunity, it's not getting disturbed by the others. Like how you exist, likewise, someone else also exists within your system. So you should not disturb others and also should not get disturbed by others. That's what it talks about EMC and EMI, right? But you are seeing some of these numbers, right? So these are nothing else, the reference compliance number. Let's say like if you are making a product, so you want to go reach out to the European Union or the let's say American Union, or you are reaching out your own country, India, right? So you have to reach out BIS, BIS. So Bureau of Industrial, you can show the BIS. So BIS actually used also having the similar kind of regulatory compliance. So you need to ask like, okay, what are the things I need to follow? So they will give you a list of these numbers. So you have to go 610043, 439, 48. Likewise, you have CISPR 11 or FCC 15, CISPR 32. If it is automotive, CISPR 25. Likewise, they will give you these numbers, and you need to get tests at the lab and make your certification ready before sending to the custom. Okay, so that's all about fundamental of EMI EMC, right? So now if you go for the key EMC standards on the regulation, so as we already discussed, so you have FCC or you have EN 55032, CISPR standard for automotive. As we discussed that this is applicable for military as well, so that's a MIL standard. If you are making an UST robustness, I mean electrostatic design, so it is comes under this IEC 6100042. Similarly, for the space application or aerospace, it will be RTCA and DO. Medical device for the EMC standard, it will be IEC. Automotive EMC standard, it will be ISO 11452 or the CISPR 25. If it is telecommunications EMC standard, it comes under ITU, right? And you see here, I mean, this is a very fundamental, like, F clock of 9 kilohertz. So it depends, like if when you are doing a test for your product, so there are certain bandwidth also involved. And this 9 kilohertz will discuss more detail when you are going for, simulation part. So now again, coming back to the edge or the 5G. So we are actually surrounded by different wireless devices, right? So what we see here, I mean, all our wireless device with a hotspot, and this is a smart home. Now, if you look at inside, so it has like, this is how it look like a device. You have multiple antennas, you have multiple interfaces, and they have their individual functionality. as we discussed, like, I mean, other than EMI, EMC, there is something called RFI, like the siblings who fight inside the home. So if and if your interface, other than the functionality, start interfering on the antenna side. So when I say antenna side, basically you are talking about receiver side. So basically what you are doing, you are giving threat to your receiver sensitivity. It means, now coming to the generic term, let's say like your Bluetooth is capable of getting 1 Gbps speed, right? Or transferring data, or your Wi-Fi is capable of sending, transmitting or receiving at 1 Gbps speed. Because of these internal interface interference, or the radio frequency interference with your antenna or your Wi-Fi receiver, what happens that whatever throughput you have, we are talking about this one. So whatever you have throughput you have, that will come down, right? So that's come under RF descents. So it's not a regulatory, but what happens, like whenever you make a design, make sure internal whatever you have interface, they are not interfering each other. So this is one of the example for USB 3 device. So interoperability issue. So what happens here? The throughput comes down, right? So what you are looking at, so you are actually looking for 70 Mbps speed. Because of your interference, it has reduced to 20 or between 20 to 30 Mbps speed. So basically, you have purchased it, the device, for a high speed applications, but because of their internal interference, the throughput actually come down. So this is not restricted to only USB 3. So it can actually interfere from any interface to your receiver system. That's what it's talking about. And these are the different frequency of applications on the telecom side, right? So now as we are moving towards 5G or 6G, so it's a big headache for the EMC and the RF engineers, because the more you introduce the speed or the syncing of your device, the more chances to get interfere or get disturbed by others, or you can disturb others as well. Compatibility, immunity, and the self-interference. All three comes together, right? So that's the challenge part on the from the EMC side. Whenever you introduce, let's say I have made an super IoT, very small cell, capable of going anywhere. It means that you are introducing again to the EMC engineer, it is capable of radiating and violating all my limit line. So make sure that it shouldn't. That's what you are telling to an EMC engineer. So you are telling to the customer saying that I have made a robust, smallest, and the quickest, having the super fast latency. It can actually transmit 10 Gbps speed. It means you are telling like, okay, it is working at the high frequency side. It can radiate a stronger field. So you have to shield it. And at the same time, you have told the customer saying, I made it cheaper as well. So you are making something at the high speed with a high latency, but with a low cost, which is just opposite happens to the EMC side. So that's a challenge. So, I mean, we have already discussed about that. So that's why, to meet those requirements, you cannot have a compromise. So that's what it tells, what's the point? Like, if you miss any of these particular topics. So now the question comes like, when I make an electronic design, how it looks like. So this is what you get, EMC measurement test report. So what we see here for any given UT, so these many tests is required. So I don't want to go very detailed. So unless until you are not introduced, looks very boring. But you can see, so for a given electronic design, I mean, this is the report. It's available in the Google. You can actually see it. I mean, you can see the product also. That particular product actually having so many tests, like how we do test, right? So this involves the cost. So whenever you are doing the any kind of test, so it involves the cost. The cost involves starting from your lab to the test lab and coming back, because you are not goldsmith, which will you have designed it will pass. It means that if you are passed, I mean, at the first, you are really lucky. But most of the time, you get failed because of some minor mistake. So because of that, so these many tests, these many costs will be added till you pass it. So this is what it tells. Like if you want to do full FCC, FCC stock, you have to spend around $5K. Full FCC certification, it will be $10,000. I mean, these are the different certification if you do. So almost this will be, you'll spend for every product. Plus you have this additional cost. So let's say if one goal, if you do this many uh, test will be, I mean, test will has to be done, and this is the cost of your the whole process. So this is all talk about, like, and in case if you are not introduced the design, so I mean, to pass it the lab, so you have to pay the money. So what we see here, I mean, if you introduce the, your design at the pre-compliance test, so it is quite possible, like you can identify before going to the lab, and I mean, you will fix it and send to the lab, so which will actually reduce your cost. So, I mean, that's a ideal physics. I mean, it's a old school physics. Think that before going to the given test, you have a, let's have a pre-test. I mean, if you see, I mean, before any exam, we have a pre-test kind of the similar thing. That's called pre-compliance test. That can be in your lab, or that can be another lab, which will be cheaper in solutions, right? But still, unless until you are not qualifying here, still you have to repeatedly, you have to do it. So what we like, if you don't do it, I mean, this is a comparison. So let's say, like, I mean, if you are going to directly to the test lab, and what you spend time, you will spend 15 weeks with $91,000. So this is given product. So the product cost is not involved. This is like you made an X product. The X product has to pay this much money if you want to sell different type of region with a particular applications. So it takes your 15 weeks and it takes your 91K dollar. But what if like you have a pre-compliance, like if you have done inside your lab, so that 15 weeks reduced to 9 weeks, and whatever money you spent earlier, 91K reduced to 43K, almost 50%. So that's your, reduction in time. So it is always good, like if you introduce your pre-compliance in-house, so you will actually, save a lot of money. So from the EMC point of view, what is, saving money? So if you introduce this pre-compliance in-house, this is 1.9 million revenue, because any latency, latency means any delay to the market, that will reflect your revenue as well, right? So first of all, you have to spend money to get certification. Till you didn't get, you cannot launch the market. So you have to spend both. So this is what actually your gain. So overall, like by introducing a pre-compliance in-house, you save $1.9 million. And whatever the delay, that also actually compensates. So that's what actually, from the money perspective, the cost aspect, like when you are making a, especially when now the ecosystem is all are talking about startup. So when we say startup, it's not nothing else, it's the money, right? How fast you are actually accompanied with your ecosystem, saying that you are aware of such things and you have taken care at the beginning. So if you do that, probably you will save a lot of money, and that will reflect after 2-3 years, not immediately. You may not be aware of, unless until you didn't qualify it, you couldn't reach out. Now, going back, what are those equipments? Like, let's say if I want to do radiated emissions, conducted emissions, immunity, EST, bulk current, how those equipment looks like. So this is how it looks like, right? So if you introduce the pre-compliance, at the pre-compliance, if you do with these equipments, probably you will solve the problem early, you will save the time, save the cost, right? So when I say save the cost, what it means like you fix the product and send to the compliance lab, and by saying that, you are telling the saving the cost. It's basically what we say the patchwork, right? If something leaks out at our home, right? Whether it's the kitchen or washroom or anywhere, what we do, we patch it up, right? So that's nothing else, like we put a band-aid and we try to fix it, but that's not the particular solution. Like still the leak is still there. You just try to wrap up with the common solutions. That is the pre-compliance test needed, right? You try to introduce a better shielding, your additional shielding or additional filtering. By introducing a component, you try to stop that issue and you send it across. The best example is you might be seeing a laptop, you have a charger. So if you look at the charger top, there will be a bulkier one, right? That's nothing but your ferrite bits, right? It means that the product actually designed and went to the lab, get failed. Then this ferrite bead was introduced. Now it is a part of your design. It means like you made a product which cost you $100, but it failed in the lab. So you introduce additional component which cost you $20 because each ferrite bead is $20, right? So you made now 1 million products. It means you added 20 million product, $20 million added to the system. So you are expecting 1 billion, growth, but you lost because of, by this introducing the additional ferrite bit by 20 millions. So you are expecting 1 billion, but you got, 80 million. So that's a calculation. I mean, the rough calculation, what it goes. So what we can do before going to this P compliance, now the RFEDA tools are there. So you can do this EMC modeling, right? So this is from the ANSYS. So there are different type of EDA tools are there. So which actually, you can actually do on your laptop, and you can see whether your product is actually passing or failing. So that solves a lot of problems. So you don't require patchwork. So in the pre-compliance, what you do, you introduce additional components. So that's a patchwork. So instead of that, you will find out like why my product is getting failed itself. So you'll try to fill, before making it, or fabricate it, you will introduce here itself through this EMC modeling and try to fix it. And it covers all your, regulatory. Rated emission, you can do rated emissions, conductor emissions, rated immunity, EST, and bulk renderization. So all your compliance you can do using your tools. So that's today's capability. Now, the immediate question comes, so anyway, this is through the electrical engineers, but if you look at from the EMC perspective, I'm talking about the engineers who are making the electronic product. I'm not talking about any electrical engineers. I'm talking about the engineers. So when it comes to engineering, so you have no denial to learn mechanical, thermal, electrical, power delivery, or or the CAD side. You should be aware of it, because when you are making a product, these are all part of your game, right? You cannot say I'm an electrical engineer. I just look my EMC electrical part. No, then you cannot make an electrical product design, right? You need to understand how the power delivery happens. So if power delivery happening, you should know all these things as a little bit just to stop no EMC issue from the power delivery aspect. Same thing applicable for mechanical and thermal and the CAD. So who designed the entire board. So whenever any EMC issue comes, generally it says like, okay, since voltage or current is involved, so it belongs to electrical department. No, it belongs to everyone. So if anyone actually missed it, so EMC issue will be pop up. So that's what like you need to aware of whenever, I mean, especially if you are making an electronic design. So certainly you have to meet your targets. So now going to little basics, since it is a kind of a session where we want to understand what is EMC. So this is a very fundamental transmission line. So where you have electric field and magnetic field. So going back to different type of electric and magnetic field. So you say different type of transmission line. And now if you go, what is the transmission carries? It carries your electromagnetic fields together, where E field and H fields looks like that. And by understanding this electric and magnetic field, you can actually work how this board looks like. So what we see earlier, that's what taught in the class. Like the transmission line looks like this. But actually, whenever go to an electronic board, these all are actually transmission lines. They all are netted. So almost 10 to 20,000 nets are here. They are cross each other. So that's the importance part of your EMC modeling. So with this, actually, you have to verify whether you have issues on EMC or not. So again, now coming back to the basics. So this is what we actually taught in the class. Like this is my electric field and magnetic field, and we just follow your Maxwell equations. But if you go the real time, so you see between communicating between the chip to chip. So it passed through all these power planes and the splitted ground plane, which cause a lot of your RFI and EMI. So that's actually you can do through the analysis. And coming to a little bit about the electrical design. So when you are trying to communicate between the chips, right, you need to understand like how it works. I mean, these are the parameters on the frequency side from the transmission line characteristics. So this is frequency domain where you will involve this as parameter of your return loss, insertion loss, crosstalks. But when it comes to the time domain, this is how the pulse looks like. So what you send at 1 volt, you will get at 0.5 volts. So like from the signal integrity point of view. So you saw the functionality is degraded. But the immediate question comes, where might this 0.5 volt goes? You received, you have sent 1 volt, so you have received 0.5 volts. So where is my 0.5 volt? That actually dissipated. It may be in terms of heat or in terms of radiations. So this is how it looks like. So for a given any board, so it can actually reach out through conductions, radiation. So the conduction through electric current, radiation through electromagnetic field. It can be inductive coupling through magnetic field and capacity coupling through electric field. So between the two circuits or maybe two chips, so you will be seeing this emissions resistance of radio waves, electromagnetic inductions and electrostatic induction. And when you try to connect to the outer world, so it will induce a noise and start radiating. So what we discussed at the beginning on the HDMI cable side, so this is how your cable carries your, I mean, when something is emitting from RF point of view, it's electromagnetic wave. But if you look at from the, a data point of view, you're leaking out your information. So this is how it works. I mean, it is radiating means it actually carries your information or it carries your data. So now if I go the basic of EMC, why an IC actually start radiating. So this is a very fundamental. Like, I mean, if you see a dipole antenna, so when you give a 0 volt, all your electrons are stabilized. But when you apply more than 0 volt, so then there is a movement of your electrons. So the direction of electron movement changes with the voltage polarity. Now, immediately when you move to a sinusoidal, so there will be a movement on both sides. So because of that, so what we see, it will create an E field or an H field. And this is how it looks like. So your IC, I mean, this is just a reverse engineering. So this is how the IC your look like. I mean, this is your IC. This is your signal or the forward current. And this is your ground, which comes on the return current. But if it is not properly designed, so same IC, which is capable of functioning at a different particular conditions, it can be act as a radiator. So this is what I just wanted to show. So although that's a basic of your antenna, but this is how your IC also can be radiated. It's not necessary only through the cable only you can radiate. From your PCB board or the system also can radiate. So to stop that, you need to understand, I mean, through these RF tools or maybe EDA tools or maybe certain, basic thumb rules we'll discuss at the end. So you can actually stop, doing those mistakes. So these are like, if you do the reverse engineering, so EMC is nothing else, your reverse engineering of your RF side. So generally what we do, like in the RF side, we make an antenna which is intended to radiate. But in EMC, what happens, we try to find out why the radiation is coming, which is unintended, right? So it means that it is someone's mistake. So you are finding someone's mistakes, trying to understand how the Maxwell equations work and how the antenna works. From that theory, you just try to find out the source of your emissions. So that's how, I mean, the basic of your, IC start radiating. At the beginning, what we understood, like how your HDMI cable is start radiating. Now we are seeing here, yes, your IC also can radiate. So what we see here, the pin which carries the signal, another pin which actually support for the ground can be act as a dipole antenna. So it means your IC also can act as a dipole antenna. To stop all those things, there are some basic rules, like you have to make your design robust. So this is the fundamental one we just go. So it's not limited. It's not like only those 9 rules, like, if you follow it, it will be easy. But this is very commonly used for any PCB electronic design. So again, so we are just, coming to the base of your system design. At that time, you have to follow certain things so that whether it is a 5G or 6G or IoT at the highest latency with a smaller size and robust, right? Still, you will pass it, the EMC requirement. Because as I told, like, I mean, if you fail to meet the requirement, you cannot sell or you cannot tell to your friend that you have made a design. Right? If you want to tell someone or neighbor that you have to qualify the EMC, then only the neighbor will know that, yeah, you have made a design, it is available in Amazon. So that's what we are saying. Like, so this is the basic thumb rules. Like you have to do, like if you want to make your crystal clock, which is the main source of your total processor design. So you have to make the crystal clock more robust. So you have to give more shielding. Similarly, like there are some high-speed interface will be there. And as we discussed, like you have the power planes. So the power plane, the high-speed interface can actually interfere each other. So to do that, you have certain way of keeping them separate. And similarly, if you go here, I mean, what we see in the generic transmission line, what we read in our class, like one transmission line. I mean, this is the example. So what we study in the class, we have one transmission line, we have a continuous ground plane. But in the real time, what we saw last 10,000 nets, you don't have a continuous ground plane. You have so many split ground plane. So whenever you have a split ground plane, there will be radiations. There will be leakage, means there will be degradation. What we read, like at the transmit side, you have sent 1 volt, but at the receiver side, the 0.5 volt you have received. So what we see, it's a 50% efficiency. So from the functionality point of view. But the immediate question comes from the EMC point of view, where the 50% goes out. So that's nothing else, your radiations. So you have to improve that one. So when you improve your EMC point of view, I mean, basically whatever leaks out, if you can save that, basically that will turns out to be your gain at your functionality. It means, let's say the 0.5 volt, what you lost it, if you try to improve it and you got, let's say 50% of it, it means 0.25 volt you are pushing to the output side of your receiver, means you have given transmit 1 volt. By improving the design, you now receive 0.75 volt. It means the earlier whatever 50% efficiency was there, now it's 75%. But if you make a more robust and more detailed, then actually you can get 95 volt properly. I mean, you have given 1 volt, 1 volt, you are getting 950 millivolt. You might be losing 50 millivolt because of your the traditional dielectric loss or the conductor loss. So that's what it like detailing talks about. So same thing, like it's a Faraday case. So by having a PCB shielding, you can reduce this noise reduction of 27 dB. The same thing, like there is a different type of transmission line. I couldn't spend more time on that because of restriction on the time. So here, like we try to minimize all microstrip line routing. We'll go over strip line routing over any design, which will be little costlier, but it saves a lot of money in terms of EMC. The same thing apply for having a common ground. So grounding is one of the important thing for the EMC. So if you think like in a product design, electric product design, if grounding, EMC is a black magic, then the grounding is a magician. So if you understand the magician, so certainly you can understand this black magic is nothing else a normal thing, right? So the grounding plays a major role here. So similar things like this is the heat sink. So generally, as we told, like when you put a full of stress, so it actually heats up. So certainly you have to put a heat sink, but heat sink is nothing else a metal. So EMC is nothing else like you should not see any hanging metal. So that is the important thumb rule. After the grounding, this is another one on the metal side. So you should not see any, hanging metal. So the hanging metal can actually start radiating. So make sure whatever heatsink you have taken, although this is Department of Thermal and Mechanical, it is your duty when you are making an electronic design, make sure this metal heatsink is grounded. Neither it will create a lot of other issues, start interfering with your electrical side, and it actually, from the functionality point of view itself, you will miss out. And selection of your cable. I think we already spent on the time on the HDMI cable. So what we see here, like when you have a unshielded cable, you see a lot of red spots. So nothing that's what we're calling as a hot spot. But when you have a shielded, then you will see minimize noise. So with this, actually, I've tried to, collate the challenges for achieving EMC design from the 5G and IoT devices. So if you look at like whether it's a 5G or 6G or any advanced technology, if you are involved in electronic design, you need to introduce EMC at the beginning. So these are some current work. So already Keysight and Ericsson has demonstrated pre-6G network at IEEE International Conference on Communication in 2024. So we are in end of 25. It means we are already advanced, right? And this is what we're talking about. This is a claim by the engineers that we have demonstrated. That's what we read. Ericsson is demonstrated. This is what, at the same time, we create a lot of problems. The 6G impact on EMC. What's next? So whenever you go if you go to the chronology from 1G to 6G, you are basically increase the speed, increase the frequency, and decrease the latency. you create a lot of problem on the EMC side. So this needs to understand more detail. So for that, without compromising quality and delay, as well as the costlier one, you can actually make it to the market. So for more detail, you can go a pathway on 5G EMC testing, a tutorial. It's a beautifully written, actually described about the challenges for the 6G side. Okay, with this, I will try to close one. I think I have extended almost more 5 minutes. So if you have any questions and answers, just let's have the quick one. Yeah, Deepak sir, it's over to you. It's done.
Yes, sir.
Sorry.
If in Sir, you have taken one long session, sir. Thank you very much. Starting
Right.
from theory to a practical one, very long sessions you have taken. Anyone want to ask anything? Please ask.
Yes, sir. I am Jagdish from Aditya University.
Right. Yeah, check this.
Currently, with the like our lab setup and all, how can we educate our students regarding this EMC and all? Is it what kind of job opportunities are now available in the market? So currently, whatever I saw your long session, so we don't have any such kind of equipment in our labs. So how our
Mhm.
students will come to know about all these things? Is there any
Sure.
possibility to set up a small lab like thing with minimal cost? Can you suggest us in this
Yeah.
case?
So, Jagdish, I will tell you this way. So, I mean, we are taking a course on this. I'm not telling they attend the course. What I told, like, we reach out to the different EDA tools like ANSYS, Simyok, and there are, I mean, Simyok is one of the EDA tools, which is born in India and carried by one ISC professor, actually. So,
Ah,
we reach out to them and just we requested, like, for our course, we need those, your EDA tools for free. So, in ANSYS also, we reach out the same way. I mean, it's not like that, who are you? But if your intention is for the educational purpose, many EDA tools are actually free. So you
yes,
just
sir.
apply for it. So you will get the EDA tools. So setting up the lab is a bit difficult because you should have the product also. But to understand what is EMC and implement such thumb rules, you can use these EDA tools. If your physics, I mean, the background is not all about the physics, like how it works and how you can actually improvise. So certainly you can implement on your board side at the real time, and I can actually show that improvement. But to understand that, I would suggest, like, maybe with no cost, you just first reach out to those EDA tools owner, and maybe you
Yes,
can
sir.
request them for certain time. Maybe they will be also specific 6 month. I mean, we got for 6 months. Similarly, I mean, anyone can reach out to them requesting, I want to make sure, like, for the students' educations. So can we have any EDA tools for free? So certainly you
Okay.
will get it. I mean, already it is free for the students. I mean, they can download, they can use it. But if you want to reach out to the vast audience, so that is quite possible. I mean, today's in India, it's especially, I'm not talking about reaching out to the others. Inside India itself, they are ready to give it. Even as you ask for the job opportunity, we are at the startup. I mean, you might be seeing a lot of startups are coming. So
Yes.
I'm not talking about those who are making software side. I'm talking about the hardware side. So when I say that hardware, it means that you need an EMC. So without EMC, you cannot make sell your product. And if you are making a hardware product and want to test it outside, it will be very costly. So obviously you will try to reach out your local one. And now we have so many EMC labs, I mean, across India. So it is quite easy actually. Okay, so there is a lot of job opportunities are there. I mean, I personally can tell, like, every company who's making hardware, they have an EMC team because they want to locally want to investigate and find out. Because if you want to send to outside, it takes time and the cost involves, because you have to send your product to them. They will figure it out and fix it, then return you back. That takes a lot of time, and also the cost involved for the travel, right? So instead of that, you can establish a lab. So when I say establish the lab, you have to hire an EMC engineers. So that's the job opportunity. But before that, I mean, every engineer should understand what is how the EMC works. So that's what, like, I mean, you can reach out to these EDA tools and can establish software based EMC lab. As I told, like, the same measurement, whatever you are seeing in the measurement lab, right? That same thing you can do virtually through this EDA tool, and you can establish the first one to understand how the EMC works, the physics behind. With this, actually, the maximum people can actually accommodate, understand and how EMC work, and that can translate, on your design as well.
Sure, sir. Thank you.
Yeah.
Thank you, sir.
Thank you, Jagadish. Yeah.
Sir,
Yeah.
excuse me, sir. Sir, suppose in our lab, someone purchasing any edge device like if, whatever you explained, like micro ATX or something. I
Yeah.
think that cost will be less only. It must be available micro ATX
Okay.
because that may be, suppose we are purchasing. Whether it
Okay.
will be usefully, you are thinking. Suppose we are connecting it to PC, but how you will measure it? That is the issue. That cost
Correct.
is not more. I think 5 to 10,000 maximum. It may be
Exactly.
there,
So,
but
Deepak sir, yeah. Yeah, please go ahead. Please
but
go ahead. Sorry for interrupting. Yeah.
yes, sir. But how it will be benefited? That means how you will measure it. That also require no technical
Right.
wise.
Okay. So I'll come this way. Let's say like instead of purchasing, so if you are making, let's say you are making a design, right? You are making electric design. So you will start
Yes, sir.
designing through the tools like CAD tool.
Yes.
Okay. So
Okay,
you
sir.
will place your all ICs, all your transmission line together. So you will replicate whatever you're purchasing, you will basically replicate in your tools. So the same
Tools.
PCB can be used in your EDA tool and verify your EMC requirement just to confirm that this design is not failing.
Okay,
Okay.
sir. Like
Now,
ADS, have you heard, sir? ADS, like
exactly, yeah,
sir.
ADS also can
Okay,
be
sir.
used. So
Okay, sir.
like
Okay, sir.
how ADS can be used for certain applications, right? Same ADS can
Yes,
be
sir.
used for the EMC also. So once
Yes,
that
sir.
is
Yes.
verified, right, now you can make your own design and go to the lab because your simulation tool says like it is passing. So definitely will pass in the measurement also.
Okay, sir.
Okay. Yeah.
Sir, someone actually chat box had asked, how do we
Yeah.
ensure in product design EMC? Please say again.
Okay.
Something I
So
think they must have get answer. Please explain again. How do
okay.
we ensure in product design for
So
EMC?
as we discussed, right? I mean, when you are making, when you say product design, it has to pass through. Like first, you have to identify what is your, intention. I mean, which particular where you are trying to place it, whether inside the car or inside your, for a consumer application, for a military application, you have to find which regulatory you are falls in. The second one, where you want to sell it or how many places you are sell it. It's not restricted to only US you want to sell. It all depends on you, like where you want to sell it. It means that accordingly you have to choose the regulatory. So that is the first stage. The second one, based on the regulatory, you have to choose. You have to see like, okay, what are the customer requirement. So whether rated emissions, conducted emissions requirement, humidity requirement, EST requirement. So based on that, you have to get all these reports like rated emission report, conducted emission report. I mean, whatever I shared the EMC report. That actually, I mean, the second table, if you remember, like I mean, there are so many list of regulatories are there. So all has to be tested out. After getting a pass report from individual, after that only you will get an EMC holder certification saying that this particular product actually passed. So that's how the whole process. I mean, the fundamentally this is how any electronic equipment under test goes through this process. After passing everything, then it will be called as a product. So I mean that's how we can ensure the product design is meeting the
Uh,
EMC requirement.
Sir, one more small question, sir.
Yeah,
At the very beginning of your slides, I observed one something like a proficiency course from IASC.
right.
Yeah, that was I missed actually.
Okay.
There is something like CCE proficiency course from
Yeah,
IASC Bangalore.
yeah.
Something you're offering that I missed that one.
Okay. Actually, we are offering for the professional, I mean, for the student as well. It's not restricted to anyone. So mostly,
Okay,
I mean, I see like professional, thing, but there we deal with, most of this hands-on through the CDA tools, like how you get, I mean, once you get your product in hand, so you have to do the testing, you need the equipment. But
okay, okay.
now
Uh-huh.
with the EDA tools, now you can actually do it. That's why we tells there in the course, and it's a one
Okay,
semester course like how you actually do all the simulation without going to the measurement lab. So what I told to Deepak sir as well, like with the EDA tool, it is quite possible to do the testing in the EDA tool, and it can be confirmed. I mean, it is quite established. So you will
yeah,
get a full support from the EDA tools. Support side just to establish your EMC labs. So that's what
yes, sir.
we are telling in the semester.
Thank you, sir. Yes.
Yeah.
Okay, sir. Thank you very much, sir.
Yeah,
Let's start. Our second session will start. Thank you very
right.
much, sir.
Thank
I'll
you,
get
everyone.
back you with all of that. Thank you. Thank you.
Thank you.
We can,
Thank you,
we
everyone.
will start. Yes. Bye, sir.
Yeah, thank you. Bye.
I think Devanik sir is there. Hello, Devanik sir.
Yeah, hello, good evening.
Very good evening, sir.
Yeah,
Thank you very much. We are very sorry, sir. You have waited
no issue.
almost.
These do happen. It is nothing. It is it happens actually. Second session always comes.
Yes, sir.
Takes care of the first session first. So yeah, it. Good morning, good evening to all of you. So can we start? And
No, sir. Some procedure are there. Please,
okay,
sir.
okay,
One
okay,
minute.
okay.
Sir, please start.
Good evening to all the participants once again to the day 4 session 2 of the faculty development program on application of communication signal processing and robotics for smart cities. So the title of this session is Socially Expressive Robots, a New Horizon in Urban India, and the expert is Dr. Devanik Roy. So before I request Devanik sir to commence the session, let me have a short bio sketch of the esteemed speaker. Dr. Devanik Roy is a distinguished scientist with nearly 35 years of research experience in robotics, automation, artificial intelligence, and intelligent manufacturing systems. A double gold medalist, he earned his B in production engineering from Jadavpur University and MTech in manufacturing engineering and robotics from IIT Madras, both securing the top rank. He received his PhD from Jadavpur in 1997 for pioneering work in genetic manipulation and remote control robotics. Dr. Roy began his career at Tata Steel, where he led India's first robotic application in the steel industry. He subsequently worked at the Robotics Research Center, Nanyang Technological University, Singapore, on underwater robotics project before joining the Department of Atomic Energy in 1999. At BA, Mumbai, he currently leads research on sensor instrument and robotic paper technology as a senior scientist and group head. He has served as the head of the Engineering Science Advisory Committee and is an adjunct professor at Homi Bhabha National Institute. Dr. Roy has published over 345 technical papers, 3 books, 15 book chapters, and holds 7 patents. His research spans robot clippers, flexible manipulators, bio-inspired and assisted robotics, and underwater systems. Recognized internationally, he has been featured in Marquis Who's Who in the world and received his Lifetime Achievement Award in the year 2018. An active contributor to national science and technology forums, including PST, SERV, Visual Post, and METI. Dr. Roy continues to inspire through his scholarly work, mentorship, and outreach, including writing and broadcasting on science and robotics in the Bengali language. With this short bio sketch, I would like to request Devanik sir to commence the session. Over to you, sir.
Yeah. Good evening to all of you. And it's my privilege to
Good
be
evening.
here with all of you, although it is a virtual session, but I think the MVP has been made in a nice way, the planned program. And I requested for this slot because of the weekdays sessions. And I am very thankful for accommodating me in the session. So without wasting much time, let me start my slide by sharing it. Just a minute. Well, is my screen visible?
Yes, sir.
Okay. So I am just little increasing it. Sometimes that full screen doesn't work much in the network. Just a minute. Okay, good evening to all participants. So this is the topic I was given to speak for: socially expressive robots, a new horizon in urban India. First of all, I must say, when I got this invitation, I got this topic, I was quite elated because it is a subject which is very close to my heart and it is almost my very recent research area also. So I immediately found it very apt for speaking before you. And this is all the journey which I will be taking with all of you, or rather, I will take you all on board for the next 1.5 hours, will be all mine and my group's achievement over the last, say, 5, 6 years. Very recent progress in the socially expressive robot. This is a very new areas of robotics research, and especially in India. And this is having a lot of potential, especially for the urban India and of course for all over the Indian citizens, but definitely I will speak more on the urban community of India. Now, this socially expressive robots has got a linkage with another very interesting area of robotics research in for last, say, uh, 12 to 15 years. That is also a very new area that is called bio-inspired robots or bio-inspired robotics. So these bio-inspired robots and socially expressive robots, these are actually a kind of a, you can say, sort of a mother-daughter kind of a relationship. They have a very huge deep linkage, and I will speak on those linkage in my lecture. And definitely artificial intelligence is one of the bridge between both the issues. And these socially expressive robots which are having some kind of a emotion, some kind of a feelings for the human, through which, I mean, to which it is catering the service. These are nothing but sensor instrumentation. So essentially, I call it sensor instrumented intelligence, which actually is going in the socially expressive robots domain. So in all the products that I will be explaining, uh, will be all having the sensor instrumentation very much inbuilt to that. So this is a kind of a short summary slide of my own work over the last 10 to 12 years. And this I started working from bio inspired robots, and slowly I moved to socially expressive robots in recent past. So that is the reason I thought that I will start with a slide which will be a precursor to socially expressive robot, and this is nothing but the bio robots. Now, this biorobot, although in today's talk I won't be discussing these biorobots at a length, but I will take some glimpses from here and there so that I can tell you about the linkage that I formed myself. So I took the initiation, and mostly you can see I have given the years also. And actually, it started with a small activity and the area 2000, 2018, 2018-19, and that is a kind of a snail robot I developed called Crawl, and which lead to another interesting product called Leech robots, which are in the 2019-22 domain. And then so many new things started actually with crawling type biorobot, rolling type biorobot, rolling capsule type miniature robot, and finally the worm robots, which are actually the precursor for my socially expressive robot. So all these technologies are indigenous, and in Department of Atomic Energy, especially in BARC, we are having lot of embargo problem. We cannot buy any US product or maybe some UK product also. And that is the reason all our technologies are very much homegrown, very much indigenous. And in my case, starting from A to Z of the design to implementation is all mine and all our effort. So this is the domain of bio-inspired robots, which the success of this domain actually inspired me to take up the next domain of socially expressive robots. And here also I have taken so many inspiration from biological creatures. So I will take you in the next slides that in socially expressive robots, there are actually two broad verticals. And one of the major vertical is essentially the animal kingdom. And I have taken clue or inspiration from some animals like penguin. I have got the inspiration from the bird penguin, and I developed the product called Secure in 2025, 2024, 25. It is still going on. It is a very advanced stage of manufacturing. Then baby elephant, I designed the things for something called Eureka, then frog, then monkey, then something called other things are also there. And also in the same manner, there are a lot of assistive robotics kind of project that is there are also a robot, so they are actually a social environment robot, and these are actually assistive robots for domestic care, like spherical robot called spheres, power and arrow are robotic wheelchair projects, and assisting feeding and empathy robot called flex first. So I will be touching upon almost all of these events, because all these projects are at different levels of completion, different levels of kind of a realization. So depending upon the levels of realization, I will categorize those things. Yeah, so that what I was telling, actually the concept and realization of socially expressive robots, I call it in short form ACR, are still very nascent in our country. That's the major important point, actually. So 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 these are very nascent in our country, and that's the reason the researchers who are interested for these ACRs, they have a lot of open domain to play around, and they can do a havoc. Two broad verticals of R&D are possible. One is the humanoid kind of ensemble, another is the non-humanoid kind of ensemble, and both A plus B can give you something called assistive robotics. So this is the overall domain of ACRs, assistive robotics. In assistive robotics, there are so many other elements also, and basically ACRs are the subset of assistive robotics. That is the we can simply call like that. Now, humanoid ensembles are something which is still in a very nascent stage in our country. Not much of things has happened. You might have seen somewhere in restaurant, somewhere some kind of a mobile human like structure is coming, but those are actually not a humanoid. But basically these are still to go. But non-humanoid ensembles have come to a large extent. I was just referring to the biorobotics to be very specific. So the traditional mold of this robotics for the use of common people is actually less explored. So these less explored areas have attracted my attention, and I thought that in our research, let us put some ingredients for this kind of a robotics for common people, so to say. Okay. And basically, from the advent of robotics in the 1980s, okay, for the next 20 to 30 years almost, these are actually the industrial application of robotics area, robotics domain. And it was almost saturated. It is now almost saturated. So it is a time for us to look around for the social sectors, non-industrial sectors, etc. So that's what I have written over here. So there is a lot of scope for home sectors in India, social sectors in India, where we can play around the things. And basically, these are actually various domains. I will also give those details, like you know, nursing, caregiving, as a assistive systems, feeding, then you can say locomotion, all those things. Even in agriculture, security, defense, everywhere we can have a large applications of ACRs possible. But in the projects that I will be basically highlighting here, these are actually for some different categories. I have mainly focused on two categories of our citizens. One are the elderly citizens of India, another is the children who have some problems, basically the autism. So my first ACR project is basically for autistic children. So this I will explain at a later stage. So that's what I was telling, that the overall gamut is assistive robotics.
Excuse me, sir. Sir,
Yes, yes.
sir, if possible, please do that full screen, sir. It will slide show, no? It will look good. full screen
Yeah, it
will
is
come.
true. But
So,
what happens? Please tell me as soon as you are not receiving that thing. I can make it full screen. But what
huh,
happens
sir?
mainly for the bandwidth problem? Sometimes it happens. I am making it full screen
Oh,
now. I am making it full
okay,
screen,
sir.
but you may get a problem.
Oh, like that, huh?
Yeah, it happens. But sometimes it may not happen. Like right now,
Oh,
I have made it this slide as a full screen. Is
oh.
it okay?
But it's the same only coming, sir.
No.
Same only
I
coming.
in my laptop, I have made it full screen.
Oh, no, no issue, sir. Please go on, sir. Okay,
Okay.
carry on.
So,
Okay.
okay. So this assistive robotics domain is actually, as I was mentioning, it is slowly emerging and they are branching out to several areas of healthcare, companionship, guidance, daily course in various social and home service sectors, including agriculture, rescue, and surveillance. So this is the total domain of assistive robotics and of course the socially expressive robots also. We have something called exoskeleton. We have, of course, mobile robots already, but those are not exactly the thing that we are expecting from the ACRs because ACRs have a receptive signals possible. And these ACRs are, as you can say, must be very person centric, and this should be a customizable. So all ACRs are actually a customizable products, unlike the mobile robots, unlike the exoskeletons, etc. So ACRs has to be quite a person specific or a cause centric. Like if it is for elderly persons, ACR's design will be something. If it is for the children, it will have a different perspective. So that way it has to go. So I have given some details here, but I am not explaining because of the paucity of time. And this actually, the need of these expressive robots are for several options, several reasons. Autism, I just told you, or a mild to severe dyslexia. So those are the disease that is very prevalent in India, but almost it is going unnoticed because there is no such collected data even at the government level. So all these effects have actually triggered my planning, and I thought that I must do something for these sectors, and I mobilized some of the enthusiastic researchers, and we are at some level of achievements now. Okay, so these are the some of the details, and then one very interesting thing that came into this when I started doing research on the ACRs, and I found the global scenario. I have found that majority of the researchers all over the globe, they have done it for animal like systems, or maybe they have taken inspiration again from the biological creatures. So again the bio inspired robotics comes in the picture. And like in China, they have developed a CR that is made for this kind of a autistic children, but they have done it, made it with the shape of panda robot they call it. Now that particular animal is very common in China and many of the other European countries, but not in India. Now when I was going through those research papers, I found that this is not help. This will be not a good replication. So I have to think something very much Indianized. So I thought baby elephant, I thought penguin, I thought monkey, something which are very common where our children, our persons can relate to those animals. So these are the kind of a, you can say again, a Indianized context for that. Okay, as we are doing it for benefit of citizens of urban India, then we must do some designs which are actually Indian designs. And in that connection, there are a big role that artificial intelligence modules can play. Of course, India is progressing very fast. We know a very good research groups. I mean, at several companies or several institutes, they are working very hard. But I must say at this moment that those modules, whatever is available as of now, these are still to be a kind of a theoretical or maybe some kind of a, for simulation it is being used, not for practical application. No such good product in robotics or robots has come up yet with an AI is functional. So sometimes I, in a lighter vein, I tell that it is a implementable AI that is required which is the inverse of AI, is actually the requirement for the hour. So with this kind of a background, let us do a serious checking of what are the ACR prototypes can fulfill. So this any ACR prototype must fulfill the following 6 objectives, and these are extremely important for designers to understand, for any researchers to feel the pulse of it. First and foremost
Excuse
is
me, sir.
caregiver.
Sir,
Yes, yes, please.
sir, sorry, sir. Sir, slides are now not moving, sir. Just fix it is. Sorry, sir. Now it is okay. Now it's
Yeah,
11
that is
number
the
slide.
reason. Actually,
Preview,
I
sir.
told that this is my experience
Oh, okay, sir.
in
Then,
a
sir,
slide.
please,
No,
like previously,
let me
please do, sir.
go through this only. Anyway, you are recording, so I think
Yes,
afterwards
sir.
you
Yes,
can
sir.
even
Yes, sir.
continue.
Like previously, sir.
Yeah, yeah. So I will try
Now
to
it's
explain
11.
as best as possible so that even if you cannot see it properly, at least you can
Yes,
get
sir.
the
Yes, sir.
essence.
Yes. No,
Okay,
no issue,
okay.
sir. Okay.
Okay, fine.
Thank you.
So we are at this slide. So where the first and foremost duty or first and foremost design objective of ACR is caregiver. So it will work as a caregiver. So this is the very important thing for any ACR to achieve. And as you know, it can give in the form of feeding assistance for feeding, providing medicines, monitoring health parameters, etc., etc. So this is the primary objective, and this is these ACRs are predominantly indoor ACRs. Then second is companionship. This is another vast area of ACR where these prototype ACRs will be having some kind of a friendly environment, empathy generated system. And it's not very easy. I mean, it is a highly deep AI and other modules are required for doing that thing. I will show in some of our test videos later on. So senior citizen or children or both, they can have this companionship by auto typing, typed message, and all those things. So companionship is the next parameter. Third important parameter is general assistance. So assistance can be having a various type. Assistance can be even in the form of a giving suggestions. That robot ACR can give the human some good suggestions. So this can be also possible in the form of a assistance. The fourth one is limited scale mentorship. This is another very, you can say, the next level of ACRs we can achieve, we can plan for achieving it. The mentorship, where robot will go a little high in thinking compared to the human. So that is the kind of a mentorship. Okay. And especially it can do a good thing, good job for teenage persons or somebody who is in some dilemma. So this mentorship is very much possible. Fifth one is tutoring. It is a vast example, and in India especially, the country which is, we are a populous country, we are a lot of new generations, mid generations are there. So tutoring is a very important thing where robot can teach lessons to a large audience. So that is called tutoring examples. And finally, the task scheduler. Task scheduler is very much essential that the way the life is progressing, all of us, not only the senior citizen, but even the mid senior person, they also need somebody to help him or her in daily task scheduling. So this ACR, one of the duty of ACR will be this task scheduling. So with this kind of an idea, let us go to more on technology side, because these are the preambles kind of thing. In the technology side, of course, we are having two broad verticals. One is the mechanical design and manufacturing and fabrication, etc. Another is the electronics, software, AI, and you know that lot of interfaces. Now, ACRs, unlike the industrial robots, or laboratory, tabletop laboratory kind of a robot, ACRs must have very robust graphical user interface and HMI, the human machine interface. These two are very, very important for any ACR designs to function. And without that, we cannot do. And that's the reason when we started doing the basic conceptualization of ACR, it came to my mind that we have to have a very good, robust design for that. And these designs are not only for the body of the ACR, but also its manipulating members. Now, what are the manipulating members? That means it must have some hand or some kind of a limb that will do the task with the help of grippers. So this is the conceptualization of a ACR. Okay, so that's the area where flexible manipulators comes in the play, and by virtue of my previous research exposures in flexible manipulator system, and a lot of product developments have been made and YouTube videos are there, so I have just given in this slide some YouTube this thing. So if somebody is interested, one can go through it, but I am not detailing it out. But that knowledge actually helped me to take the case of a full design of the ACR. So our research focus was to design and develop a unique ACR, a truly assistive robot, and which will be equally responsive to the need of the persons we are targeting. Primarily, we targeted elderly and autistic children, as I was mentioning. And this particular thing has come from another stigma, which is essentially the various designs of toy robots. Now, toy robots you have all seen, and even these days, children are playing with the toy robots, and these toy robots are actually a kind of a very good clue for the basic design, mechanical design of the ACR to start with. So essentially, these toy robots, if you just see, they are actually, some are humanoid kind of a shape, humanoid robot, some are animal shaped robot, and some are science fiction based robot. So this is a large, three broad verticals where the toy robots play, and we can have all these things in our system. So with that background, I think around 2023 or maybe early 2000, late 2022, I started venturing in this kind of a socially expressive robots, and there are four of that. And this slide is a very fundamental of that slide. First socially expressive robot is secure, socially expressive companion universal robot for education and learning, that I took the design in 2023, early 2023. And secure is the first one, which is now in regular operation at the doctor's clinic, and soon it will have a kind of a you can say maybe a commercialization also. The second project that I embarked on is Eureka, Expressive Universal Robot for Extensive Kinesthetic Assistance. So this is also a socially expressive robot, but with a little difference of than the previous one, is called kinesthetic assistant. That means it has got a feeling of kinesthesia. That means it will respond to feelings and touch. So, conceptually, it is a little higher up than secure. So Eureka is in the stage of final design process from the mechanical side, and we are just moving fast from the controllers and other instrumentation part. So that is the status of Eureka. That's the reason I have made it green. So this is design and manufacturing is done. The other two projects are basically still in the design stage. One is Rose, robot with occupational and social empathy, and Spark, spherical, piezosensitive, articulated robot with kinesthesia. Now, this Spark is actually an offshoot of my own project Spheres, where we developed a spherical robot last year, and it is an extremely, you can say, knowledge giving experience for me and for the team. And so that actually compelled me to take the case of Spark. So these are the actually projects that I will be mentioning further. So here actually this slide, of course, I have shown you earlier. Yeah. So this is the kind of a prelude. There are two preludes basically. One is essentially the robotic wheelchair that I will take up little later, and the other prelude is toy robots that I was mentioning. You can see that if you see very closely the galaxy of these toy robots, you will get the three major things: humanoid, non-humanoid animals, and kind of a friendly gesture or kind of a sandwich between these two kind of a thing. So this has helped me conceptualizing the ACRs. The other important thing is essentially with the kind of a system where we can have mobility also to the ACRs. Now, if we have to think of a mobility to the ACR, because ACRs cannot be a static robot, that is a fundamental thing. The design outline of ACRs cannot be a static robot. So they will be mobile robot, but not in the form of a standard mobile robot either. Okay, and these will have some kind of a feelings for the patients and all. So in both way, whether it is a kind of a robotic wheelchair, that project will come separately, or it is a kind of a improvised toy robot with some kind of a feeling. So both are actually the pragmatic things for the ACRs to be designed. Now, so far as this electronics and controller, that is also very important, because this will have a lot of similarities. So whether we take a Secure or Eureka, Rose, etc., most of the cases, the basic control mechanisms are almost similar, except the GUI HMI part. So I have considered those in a small unique module like this, as you can see in the picture. So there are two modules. One is the module one, another is the module two. The first module I am calling as the basically the HMI etc. console, which is extremely important for ACR, because that is the console through which it can have the feel of the game. And the second module is essentially more on uh, control system development with motors and softwares and all those things. And of course, all the technologies what mobile robot technologies are adhering, that is SLAM, simultaneous localization and mapping, and other things, and sensor driven things, these are all applicable for ACR. So most of the navigational things for mobile robots are can be taken for that. In fact, that has grown, that has become very stable in our country also. Now in India, we are manufacturing full-fledged mobile robots with our homegrown technology. So I thought all my ACRs or even my robotic wheelchair design, they must be built on the mobile robotic technology, because that is more of a stable technology that we have already come across. And you know the standard systems of mobile robots, sensors, that lidar or camera or any other sensors, like proximity sensors etc., we can use, and the technologies are available for there to sustain. And one important thing here is very much important, because whenever we are doing any indigenous development in robotics, okay, whether it is ACR or something else, these days, at least in today's time, we cannot have anything other than ROS, okay, the robot operating system. So ROS is something which has gone very fast, and as you know, the we have every day new versions of ROS is coming, and they are very much open source. It can be accessed by any researcher, and we can plug in our own module in ROS, and that can be tested also. So by default, we do not have any other option other than using the ROS for our ACR, as you can see. So one important idea, one important technical feature that for all ACR controller is target seeking behavior. So this is a very important thing. Now this target seeking behavior means it is either it can be a guided locomotion or a kind of a free locomotion, like when the ACR is not having any duty, or it is patient is say sleeping, or patient is not somewhere in the vicinity, then the ACR can have its choice of a free mobility. So that free mobility is essentially the mobile robot kind of thing, okay, target seeking. But when it is interacting with the patient or interacting with the human, then its behavior will be totally different. Like it cannot afford to go around and hit the patient by virtue of its locomotion, and at the same time it will also respond to his query. So then that is not possible. So this target seeking behavior is a very important kind of interlock that all ACR controllers must have. So that's a very important precondition that we should know that how it happens actually. And for that, in order to have this kind of a situation dependent decision, we can call it, the way human can do it by virtue of our brain. Now how you can incorporate this situation dependent paradigm in the ACR? There is no other technology other than fuzzy controller. So ACRs must have this fuzzy based control system, because it is extremely important, and we can really have the practical application of fuzzy control. And in our system also we have used it, although still some more advanced research is going on, but whatever we have developed is something that I can present here. So we have lot of linguistic terminologies we have used. We have started with very simple three or four linguistic phrases like fast, medium, slow for the kind of a pace or the speed of the ACR. And also we have used terms such as far, median, or near, like this for the location, respective distance between the human and the ACR. So that's the very important thing, because it is actually having a empathy based communication with the human. So the distance matters. Otherwise, if it is at a far distance, like robot is too far from the subject, from the human, then many of the technologies may not succeed, may not be successful. So that's the very important thing, which mobile robot doesn't have. Okay, mobile robot is not speaking to some person in that sense. So it can have a duty specific operation, but in ACR we cannot have it. So we started with basically triangular fuzzification process, which is the most standard membership function in fuzzy. I will show you. And then we have developed several fuzzy rules for that. So this is the fuzzy simple fuzzy controller that we started with. And we have made something called several define the membership functions like right target, left target, front target, head angle, forward velocity, backward velocity. So these are the membership functions that we have used. Okay, so six membership functions to start with, and these are giving pretty good results in our system. This is applied for the secure, and to some extent we have just started for Eureka, but for secure we have actually done the needful. So the target, I mean, in the left and right notation of the target that we have called. So right target, left target, front, head, and head angle, etc. So that way the system will actually proceed to the system. And this is a more detailed fuzzification, like fuzzy membership function details of the the way we have call it. So I am not going to the mathematical part of details of that. And we have, of course, those have been codified. And then a lot of fuzzy rules we have developed for our more locomotion, fuzzy rule 1, 2, 3, etc. That if then kind of block, as you know. So the way we do it in our programming languages, the similar programming systems are actually there. So this particular fuzzy based motion control or emotion control, so to say, are very effective, and in secure we have done for that. And also we have started using some advanced linguistic terminologies like go, stop, left, right, pick, drop, keep. So these are the things we are planning to do, and some of the things are already being taught to the robot. But hope we'll be able to do the needful in near future for that. So these are some kind of a technology blocks for the fuzzy controller for the prototype ACR. So that is the way it looks. Okay, and for each and every semantic junction, the fuzzy controller will process the things. It can be little slow at times depending upon the processors and other details, but finally it will give rise to the system that is at our hand. Okay. And what we have done for ACR, sorry, for the secure, to be very frank, the video I will play, and then we have started with very simple expressions like sad, then painful or morose or something like that, and we are actually teaching the things, or the it is vice versa. That is when the patient is showing that particular kind of a facial expression, that robot is able to tell that what kind of facial expression the patient is. So that's a very important attribute. And you know that the study shows that for the autistic children or the children with dyslexia, they actually fear the humans. That's a very interesting paradigm. Even I was also not aware when I started researching on this. So the research says that they are actually fearing human. That is the reason most of the ACR designs are non-human. I mean, non-humanoid kind of thing, mostly on the friendly animals. So they are more open to friendly animals. So like in China, etc., they started with the panda. So that is the reason we thought, let us have some friendly animals of Indian, like baby elephant, like penguin, like small monkey, etc. So that's the background of those ideation. And all this systemization of this thing, when a fuzzy controller works at the background, several of its processor things has to be done. So all those things we have taken care of to kind of a low level calculation for these operations. Of course, the AI modules are extremely important. So AI modules are definitely having some good input. So what we are doing, because these days many open source AI modules are available, accessible, and we are plugging in those things in our ROS, because our basic platform is a robot operating system, the ROS platform, and in the ROS we are plugging in those AI based modules actually. So, and that gives us a freedom of doing many of the good experiments, and that is the reason we are doing. Even we are taking the kind of a advanced slam things like ORB slam, DRD slam. So those we are actually taking access from the open source things. So this is more or less a kind of a background of that. I will come to the details of this ACR design, but I will just take you a little detour of some interesting biorobotic feature that has helped me conceptualizing this ACR. So that's a very interesting thing. So I thought that I may take some 5 to 7 minutes of the time of the audience to do that thing. Now, this is one particular animal called armadillo, which actually took my attention quite some times back, and I thought that I must do something kind of a rolling robot out of it. So this animal actually can roll, and they roll and they make the locomotion through rolling. So that's the very interesting thing, as you can see here. So animals is big size, but it can roll fully and then it can go to the locomotion. So that has helped me conceptualizing my rolling type biorobots also, and afterwards also. So this is the principle that I will show you the schematic in the latest of the ACR, the Spark, which is a spherical type of robot design with piezoelectric sensors, etc., etc. And I have given the shape of a monkey, but basically the rolling is being attributed by this armadillo kind of thing. So this is a very interesting creature in nature. The other important creature that can roll is pangolin. Pangolin also can have a rolling feature. As you can see, it can squeeze and roll. So it helps. So in my Spark project, to some extent in the Rose project, these effects have actually, I have incorporated the things. So you can see the natural rolling of pangolin. So it can just, in a very small volume, it can manage itself. So these are the inputs that actually helps the designer. And as I am telling quite repeatedly that non-humanoid based designs are the essential items for ACRs. So we have to take care of the biological systems. The another system that is also very important in this kind of a rolling motion is called hedgehog. And hedgehog can also, kind of a squeeze itself in a kind of a ball sort of a thing. And this kind of a special lizard, this also have a lot of essence in that kind of thing. So you can see the natural rolling of hedgehog. So it is actually able to roll in a very nice way. So all these animals actually influence my design process once in a sometimes back, and that is the source of this thing. Similarly, this golden wheel spider, although it is a spider, but actually this has given me a kind of a clue for rolling capsule-like systems and all. So if some days we have to do some ACRs of a small volume, then probably these designs will help. So essentially, this biorobotics and socially expressive robotics, that is what I was telling in the initial first slide. They are actually the common thread. So one is quite, intermixed with the other. And as we have advanced with the technology of mobile robot plus the static robot atop, and that actually gives the basic clue for the design of all ACRs. Nonetheless, the biological part is very important. The bio-inspired robotics, as we call, we have seen so many developments all over the world, and then uh, those are actually the clue. And in that sense, my research also progressed, and then we have got the ACR. So in different phases, I have researched, and then we came to the level of ACRs now. So I will quickly show those kind of a thing. This is one of the design that we make for robotic leech, and this concept was used in the Eureka project actually in the ACR finally, where a kind of a crawling and rolling are together. We made it full indigenous development and very small items. It is for surveillance. Now, some of the ACRs are important for rescue and surveillance, as I was mentioning, and even there is a national level thrust for doing that thing. So if it is a kind of a surveillance, then we must have a structure that it can go along. We cannot afford to make a very huge robot for that. So this is the some kind of a prior arts that helps us to do that kind of a thing. So these are extremely small volume, 20 millimeter by 20 millimeter cross section kind of a thing. So you can imagine the small cross section and how we can technologically we have made the things. Of course, this I am not detailing out much. Some of the YouTube videos are there, so I will probably refer to that. One can see if it is in they are interested. And I think this YouTube I will just play a little bit, but not much. So here we have given, also we started with a third based technology, and here it is given that with a curvilinear surface also, this can go. Okay. So these are the things that happened. So all these design technology are helping us to take the decisions for that. And there are of course rolling systems also, but I think I let me go a little fast and show some of the videos only. So this is actually a rolling kind of a system, and you can see by a special technique, by a special physics actually, we can make it roll plus progressing over a curved surface like this. So many such things are possible. And then we passed on to some of the things of with more miniaturization and more sophistication. Similarly, we progress for a lot of control based systems. So these are very interesting control architecture that by two motor and then separate control for the legs and all. So all these creatures are having legs. Okay, so like tomorrow, if we do not make a if we want to make a ACR with legged system, then how the systems will look like. So that is the reason we started with all this kind of a very fundamental technology. Another fundamental technology is here is basically with the rolling type by robot and crawling type by robot, and so those are the fundamental part of it. Okay, let me just show some of the basic pictures. Like here, the how the systems are going actually. So kind of a leg and wheel, both are interested to that particular thing. Okay, so I will just go through some of the major part actually. I think just a minute. Yes. I think I want to show one more good video that will help us. Yeah. So this is a very interesting biorobotics project that we did, and that has helped us conceptualizing many of the grasp and other things with the flexible universal modular biorobot. And it is actually a project that has happened very nicely. It is a part of my DST project earlier, and this was developed with a technology collaboration from a company in Pune, my participation. So here we are actually experimenting that how nicely we can have lot of degrees of freedom to a single link flexible robot with a gripper. And as you can see, whether it is a wheelchair or the ACR, we have to have the flexible manipulator attached to it for the purpose. So this project was taken with the aim of doing that particular thing, and it is successfully doing the things actually. So you can see by the programming, you can make it really kind of a carved link, carved beam, and it is also able to grasp at that location. So that's the beauty of the system. In fact, this project was has given me or given us a very good confidence over a lot of indigenous building of the system. Okay, fine. And this was extremely praised by lot of media that time. You can see the Indian Express cutting that we have developed with collaboration with NIT Rourkela, and it was very nicely developed. The other areas where actually ACRs can help in the kind of a small robot is the worm robot. So these worm robots, I started doing kind of a basic research and making a small worm-like structure for agricultural use. So let me just show the schematic of that. I think just a minute. Yeah. So this particular system having got three portions, the frontal, back, and the middle one with a spring-based connection system. And this is actually a very good design for the ACRs also of different kind of a structure. So that kind of a structure, so that particular essence has come from that. The other interesting feature is the spherical robot. As you know that that Spark, the last one, is a spherical type of ACR. Now, if it is a spherical type of ACR, so I started the very basic design with a spherical surface with a base and a particular manipulator inside. So that was our starting, and then we started experimenting on many such things and the designs, etc. My scholars and students, they worked very hard, and we patented also. And this is the final product, that final spherical robot that we could achieve. And it has a so right now it is for the surveillance purpose, and then it can have the mobility, etc. So we will do it, and it is fully indigenous, and is a very very good product for doing the things. And these are the some dimensioning of that things. Okay, so I will now go through the I will come back to the ACR again because time is short. Yeah. So the for all ACRs, the major thing is SLAM-based LiDAR navigation with human following mode. So that is very much important, and that way we have to do the thing. So these are the some of the basic features of the motor skill and all. And here is the our companion robot, the first developed artistic and 3D model for that. So we actually brainstormed on many designs, like a little kangaroo was also thought of once. So finally we landed up, or finally we zeroed on penguin, and you can see that every part has got meaning. It is not just for aesthetics, but it has to be aesthetically beautiful also. So because the children should like it. So these are the some of the our design dimensions, and then uh, this is the exploded view of that. We have the lidar here just beneath the hat portion of it. This is the head, which is having eyes, that means the cameras. And we have the servo motors here. We have two flappers just like a hand, the wings of the penguin, and the base. Sorry, the major the body is the kind of a uh, fat belly sort of thing, and that will house the electronics, and also it will have a display, the HMI. So I was mentioning, that is so always whenever we have to do some ACRs, it must have a good cylindrical volume. That is a fundamental part of it. Okay, whatever the design that you can think of, it must have fundamentally the basic structure should be cylindrical, and then it will have a wheel. So these wheels are actually for the flappers for the leg. So this is the basic structure of my our penguin robot. And if we go a little bit of details, so this is the lidar sensor, and this also have a camera, and the controlling and other sensors are also there here. And we have a neck band with a camera also. So it looks like a necktie or neck band, but it has a camera. These are the servo motors for that. These are the cameras for that. If we go to the central body portion, then this is the central body, and kind of a this structure. And inside this central body, there are several such racks to keep all our electronics, all our instrumentation inside. So that's the design that we have to do, and we have done it actually. And this is the bottom portion or the flapper kind of a portion. So I have already mentioned in several forms. So it is the target user is for autistic children between ages 3 to 10, etc. So let me show some of the these are all the details. And for our experiment, we have several objectives that we started with, that how to do it and all those things. So these are the objective 1, 2, 3, and what are the skills that we have to enhance and all. And first objective is facilitate emotional understanding in autistic children. Okay, so so how we can make them friendly? They should not fear the my penguin. Okay, so penguin should be a kind of a friendly, having a friendly gesture with that. So that is our objective number one kind of thing. Then we are having objective 2, encourage communication in autistic children. So when we started doing that, several interesting things happened. First, we were trying uh, with ourselves basically, and when we gave it to the actual child, I think the video is there. Then several interesting communications happened, and we also learned a lot of new things out of that. So we have given this kind of a schematic that how actually it should be working for that. Sorry. Then objective number 4, and then objective 3 is improve social skill in autistic children. That means generally autistic children are not very social because they want to be within their own cocoon kind of thing because of their problems. So one important attribute of ACRs will be they should be empathetic to that, and then they should help improving the social skill for that. So they have to, we have to teach that simple sentences, simple wordings to be spoken by the robot, and then the children will be attentive to answer that. And after hearing the answer, the robot will do the next level of the communication. And objective 4 is provide routine and predictability in for autistic children. So predictability or routine check or daily routine kind of thing. So it will check whether the children is doing the right thing at the right moment kind of thing. So it will know all this information a priori. It will store in its own database, the penguin robot or the secure robot, and then it will do the needful. So that kind of a thing. Similarly, the objective 5 is the last objective, enhance the general intelligence through reciprocal learning. So reciprocal learning is also very important. That is when some unknown things are going on. And the last objective is enhance engagement and focus to the autistic children. So like that, it has to go for that. So these objectives have been actually decided after a long discussion with the doctors, basically. Not that we have made it of our own, and they only suggested that these are the problems that autistic children face, or many similar things are there for elderly also. As we always say, the elderly persons are next level of children. So similarly for elderly also, I don't think that it will be much different. So we can even try for the elderly, and with the same technology or same technique. So these objectives were actually framed by the doctors, so to say, in consultation with them, and then accordingly we are care with that. So I will now show some of the videos. So this is the very interesting thing. My main scholar who is explaining the status of prototyping. I think this is a small video. Yeah, actually, this video is a little old because it is as of now, as I think May or June or maybe at the most first week of July. That time we are given the printing, and this is actually the final printed things with my postdoc scholar taking the charge of the systems. And I will now show some of the videos, which is the most recent, like August, etc. So this is the objectives, whatever. So so with the actual children, we are doing. So we actually did it for, of course, the normal kid, which has a intelligence, and that is a thing. But actually, when it will be the autistic children, the things will be quite different actually. So let me just explain it because viewers may find it that what is going on. So basically, here the robot, the secure robot, is actually teaching the autistic child. Although the particular child here you are seeing it is from state of Gujarat, he is not autistic, but basically. Because we are still to get the ethical permission to chill with the actual autistic children, but we'll soon do it. So here actually it is being taught. That is, these are the faces and all. This is the call sad. This is something like that, and then robot is teaching the children. So that's the way it is happening. And then it is showing to telling the child to show the RFID card to actually which one is correct expression for that. Okay, so this is the way it is happening. Yeah, like that it is going on. So I think let me show the another one which is also very interesting. No, I think this is the same. It might be the same one. 1 minute. Okay. Yeah. Yeah, so let me just explain the things what is happening. Like the farm voice, whichever you are listening, it is basically the human. Actually, my scholar, he is telling the question, and then you are getting a finite time gap before the robot is answering. The other mechanized voice is actually the secure's voice. Okay, and because it is actually processing all the codes in between, the whatever is appearing in your the screen. So that is the reason we are again trying to minimizing that, but some of the things are okay still going on, but we are essentially able to do that thing, and you can follow the reply that robot is giving, which is almost, I mean, very accurate in fact, and it is actually a extension of what the human is thinking for that, how is your day and all those things. So we are doing with the simple semantics, simple syntaxes, and accordingly we are proceeding further. And see, the thing is, it will take some time, so I am just stopping it. But the thing is, robot is able to question the next query. Okay, ask the next query. So that's the challenge that we had initially, and it it went to a lot of coding and lot of testing, etc. And but we are successful in grabbing the things, and then it is able to ask the correspondingly the next question, which is intuitive questions to the human. So that's the way it is going on. So this is at the very final stage, and we are soon getting the clearance for clinical trial with the actual autistic children in a hospital in Ahmedabad, where actually physically the system is lying with the Gandhinagar systems and all. Okay, so I will quickly go to the other projects because time is also running out. So this is the next project, the Eureka, which is in the form of a baby elephant. It is something different from the Secure, and it has got lot of new features also. One new feature is of course the trunk of the elephant, which is actually the flexible robot or the flexible manipulator. You just now saw the video of that flexible universal robot, and how nicely we are able to control the grasp and the flexibility of the gooseneck link. So that exactly the concept, that design, the technology has been adapted to this Eureka actually in a form of a trunk. Also this time this is for the outdoor. Now unlike the Secure, which will be mostly indoor for the autistic children, this Eureka is for the outdoor mobility or for companionship, mostly for the elderly or for the children also. And that is the reason we have provided the solar cell to that for solar charging. So this is the way it has been thought of, and manufacturing is just going on actually. Right now, I am not able to show the photograph of manufactured product, but it is going on. So this is the extended CAD computer aided design model for that. So it has got lot four wheels and also the basic mobile robotic technology is still going on. So that's the fundamental thing. Whether it is a penguin, whether it is an elephant, something like that, we are not disturbing the basic locomotion by the wheels. Okay, and as I mentioned in my earlier couple of intermediate slides on the biorobotics, that rolling type biorobot, crawling type biorobot, those things are there. So those concepts are actually being used here also, although in a much larger or a bigger way. And this structure is very important. So this is a structure where even for Secure also the similar thing happened, only thing excepting the manipulator part. But for Eureka, so this is the control system structure or the actual schematic of the from the two-dimensional schematic, we can say. So we have the holonomic drive first of all. So this is also a very important case that four wheels of the baby elephant structure is there, and four wheels are all holonomic system. Holonomic system means they can run independently, they can be steered, and they can be programmed independently. So that is the thing, the way in mobile robot also it happens like that. And that manipulator sort of thing is basically the flexible manipulator with a gripper, and that will do the job. So this is the structure. The next project, which is still under the design stage, is called Rose, which is actually a standing frog, as you can see. And this particular thing has again some specialty for the flapper. The flapper like systems, which is actually the hand and with end effector. So this particularly the penguin case, we just started with the flapping mechanism and we are very successful. So that has inspired me that can we develop an integrated flapper. Now in the penguin, what happens? It was actually external part, as in the video you have seen. My student was explaining that it is to be 3D printed, or it has been 3D printed, something like that. And but here in the case of Rose, this is all integrated. So it will be a kind of a monolithic structure with a, of course, again 3D printed, but monolithic structure of the flappers with the end effector. And it has got now the antenna for the wireless communication part of it. So both for Rose and Spark, I have used now the wireless communication systems, finally doing the things. And audio and voiceover, text to speech, all these technologies will be in the case of Rose. So because the experience that we have heard from Penguin robot will be used for that. So there are some details of our technology that has been attributed, that what are the major components of this Rose robot, and those things have been detailed, but I cannot go through the details of that. And in the Rose also there are a lot of actually iterations happen, very something like a little funny iterations by the scholars or the students. So essentially we have three such systems that was concept was developed, but nonetheless the major thing is basically the wheel motors, battery, speaker, camera, lidar, all those things are the fundamental things, and overall the ROS environment. So nothing separated from ROS. We cannot really do that thing. And it will have the Bluetooth module and the LEDs and flapping system, mic, and all. So that I am not detailing out because those are fundamental things for that. And controlling of the robot, we have autonomous mode, voice mode, control mode, manual control mode, and definitely the hybrid system of operation. Um, we have a lot of interest in the big portion of the frog. So that frog, that particular thing will be using for many operations which are not there in the penguin case. In the penguin case, there were not such any such thing. Even in the baby elephant, except its trunk, nothing was there. But in the Rose project, we have the facility to develop that particular beak. So movable beak, we have planned and designed for that. And this is the last of my SER, which is still on the drawing board. It is called Spark, and you can see the idea came from our success with the spherical robot last year. And then I started thinking of late in the last year that this is the Spark that we can design with a piezo sensor array now. So piezo sensor and experiment with piezo sensor is very important, and it will have two flexible arms. So since with one arm or with one system, we are confident that we will be able to master the technology. But with double hand, how the duality will help, or duality will destroy some of the things we do not know. Because in the case of a animal monkey, so they are very well doing the coordination between their two hands, definitely like humans. But whether in the case of a robot, okay, whether with the two flexible telescopic arms and the soft hand and the soft fingers kind of thing, whether the coordination will be there or not, that we have to see. So this will be a very interesting project that way. But nonetheless, the basic features like motor controller, motor and controller, HMI screen, HMI console will be all same, and it will have a retractable platform. So unless the case of Secure or the case of Eureka, these legs in the sense that wheels were actually visible, but in this case it will be a retractable things. That means Why it is retractable? Because when it will stand, like when it will be on the standing posture, then it will have the platform ready for that, and the weight will be shared in the platform. But when it will roll, so its locomotion will be through rolling. So when it will roll, the platform will get retracted. So that's the basic idea for that. I will just take 5 minutes of your time for a very interesting project of ours that is called feeding assistant robot. So that is another essentially social robot or socially expressive robot you can call. It may not be that expressive, but it is actually a social robot where the feeding assistance is being done. And this has been a totally indigenous, Indianized product. And in last year in 2024, in a technology competition in Gujarat, it has got the first prize. So that is one of the our satisfaction. And this is the feeding assistant robot structure, and it is able to actually do the needful. I have the video. I will also play it. And these are the CAD models for that. And it will be only for the Indian food, like rice and dal and khichdi and then some kind of thing. See, in feeding assistant robots are commercially available in abroad, although it is very costly, but they are actually for different foodstuffs which Indian do not eat. So my struggle for that was that how we can make a truly Indian product where actually we'll be able to feed the patient, feed the elderly who are alone at home with this kind of a robot. So that is the actually the aim of that. And you can see several experiments we did, several trials we did for this particular thing, because it is also not that simple, because the spoon that robot will hold, it has to hit your mouth, not your eyes or nose. Okay, so all these calculations are important. The face recognition in the sense that not recognition as such, but location of your mouth is with respect to the face. In fact, very recently, I will show some of very interesting experiments, research we did at IIT Gandhinagar, where my students have done very good work for this kind of a trajectory planning for the robot, etc. For the again the uh, uh, to exactly pinpoint the location of the spoon with respect to the mouth. So this is very important attribute, and we experimented a lot actually. In fact, a lot of subjects we to tested different ergonomic dimensions, ergonomic features, and all, and we could talk that thing. And actually, this is the feeding assistant system that is developed, and I do not know whether it will work or not. Uh, Let me see whether it is. Are you able to see the video?
No,
Hello?
sir. It's static.
Oh, no, I have made it static, but just that page came or not? First page came, no?
Yes, yes,
Okay.
yes, came, sir.
Yes, sir. Showing, sir.
Sir, video not played till now.
Sir, video is not playing, sir.
Video is not playing.
No, sir. This one is not playing.
Okay. Then actually it was from the drive. I directly tried to
Oh,
access
okay,
it.
sir.
Uh-huh.
Okay.
Okay. Anyway, no issue. I mean, okay, fine. Then let me just remove it. Anyway, let me just go through the main screen and where I was. Yeah. So that is one good example of our development, and as he was mentioning, it has a very successful product. And after third version, in fact, there are initial two versions which were also good but not that perfect. So third version we could do it in 2020 to 23, and that was good. And this is one recent example of this year's only. This thing, image guided feeding assistant robot, the same concept, but we have now given the full, uh, trying to have a full autonomy of the system. We thought of a image guided feeding assistance, and then this was tried at lab in IIT Gandhinagar. And for that, we developed a particular specialized gripper for that. And this is a photographic view of that. And with a modified gripper to hold the spoon in a proper way, and then to give it in a good shape for that. And a lot of experiments were, although there is no video as such here, but we have done many experiments. And then basically it is analyzing the workspace actually, and it is locating the bowl and the human head and all those things. So the technology that is being used here is a little different from the earlier video that earlier development of feeding assistant robot, but here it is something different. So this that is the head and bowl, and the relative distance between those are actually the essential the things. So here also, as you can see, the students are experimenting on that, and we have developed the full kinematics for that. So it is a much improvised kinematics compared to the earlier one. So earlier one was much, of course, there was a inverse kinematics, etc. was there, but here we have used a lot of sophisticated algorithm for that, so that in a very small volume robot also, which we can essentially able to do the feeding operation for the patient. And so the other aspect of this research was basically the multimodal vision guided dynamic trajectory planning. So this was also achieved through several posture, the gesture and mouth detection. So in the previous case, what happened? We were telling the subjects or the patients or the person to sit on a particular posture, so that you should not, make your head move on something like that. Not much. So that robot can understand. But here actually we are having full gesture control of the and the mouth detection. So even if you make your head move or something, the software will analyze the most recent location of your mouth, your head posture, and then your mouth. And so that much of advancement has been made to make the system more easy. The way we eat it, the when we eat it, of course, we can eat to the extent of our head movement or posture movement or something. So that is the thing that we are trying, and there are a lot of programming and other issues that happen. So I have given some of the references for that, so that I am not discussing. And with the mathematics involved in that, that is the thumb extension, thumb orientation, other fingers, and all those things. So all uh, elements have been tried here with a good software flowchart backup. And that is also one good contribution for that. And then we did the experiment with this particular robot. So this is the trajectory has been fully planned. That means from point A to point B kind of thing, from the bowl containing the food. Of course, here we experimented with only one bowl, and with a very again Indianized food stuff like bhujia, like kind of a namkeen, and then this kind of a thing, and then and some semi-solid food like khichdi and lapsi, etc., dalia. All those things we tried, and then everywhere there is a minimum spillage and almost no spillage, and it is actually going to the patient's mouth with all body postures allowed. So that's the beauty of this research, and where we have got uh, pretty good success for that. And you can see the mapping part of it, like how my robot is performing. That is how it is getting posture. So it is almost following the same path that it is supposed to be. So quite a good control over the mouse positioning. So that is our latest achievement in the month of June and July. June, July, some May, June, July kind of thing. Okay, so now we have the kind of the last one, the wheelchair project. And wheelchair project, it is still in a very interesting mode. And one commercial company is also one startup company is actually doing in my guidance, and others are actually helping from the academics. So this power is basically the uh, robotic wheelchair. We have two robotic wheelchair. One is power, another is the arrow. So the power is programmable omnidirectional wheelchair driven empathy robot. So this is not only the wheelchair, it is actually robotic wheelchair. So it is a robot itself. Okay. So that's the very basic fundamental point of it. So this particular view, which I shown in the earlier slide, is now essential for this concept of robotic wheelchair. As you can see, in contrast to the available robots, available robotic wheelchairs abroad, but they are also having lot of limitation. They cannot go for stairs, climbing, and all those things. But they are having some features which are good. But in our country, there is nothing is available. The maximum thing which you can see at Amazon, which is they are selling it very recently. I think couple of months back, 6 7 months back, they have started selling, which is essentially a electromechanical kind of a wheelchair, and cost is too much high, around 60 70,000 rupees. So that is the maximum Indian product that is available in our country in the form of a mechanized wheelchair. But in the robotic wheelchair, there will be a lot of other features which can do that thing. And that's the reason I have subgrouped this research into two verticals. One is called this power that I was mentioning. Another is arrow, which is autonomous reversible robotic wheelchair. So this is also a very interesting thing, that is the wheelchair has to go at the backward, just like our back gear in the car. So how wheelchair can go in a backside and forward also. So both forward and backward movement is in the autonomous way in the Arrow project. So that's the two sub projects are actually getting tackled by actually two companies. And this is the practical view of the wheelchair that I have designed or proposed. Here also the similar kind of a concept, though I haven't changed the very basic. That is a basic mobile robotic concept is still going on. Okay, and that's the reason you can see it is a C difference from the you know that you yourself can see in the Amazon, the product that they are selling is almost pretty much similar to our normal wheelchair. Okay, so they have just put motors to make the wheels mechanized. That's much with some joystick based control. But in the case of our design of power and arrow, I have totally used my mobile robotic technology. So that technology is being used, and above that, the patient seat and all those things, and then the solar. Again, the solar part is a very novel in our concept, because in India we must use solar, because we are so much of having abundant solar power and all those things. So all robotic projects, at least the outdoor robots, must have solar system. So that's the reason in Eureka project I have used the solar cells, and also this robotic wheelchair projects I have used the solar units, and the two manipulators, as you can see, that one bigger and one smaller, having the flexible manipulators, but with different kind of grippers and end effector to feed the person, to feed medicine, to feed foodstuff. So we have used, and all the components here are modular. That means whenever some component is not needed, you can just remove it. So this is actually for the commercialization, because whenever we go for commercialization, we need a modularity also. Unless and until we give the buyer a product which he or she actually intends to buy, there is no point in making any business for that. So that's the idea for this thing right now. So that these designs are getting developed over the drawing table, like in a software, CAD software, etc. So hopefully in another 6 7 months, the whole design will be able to go for initial test setup or initial prototype. And so the dimensions and other things have been always chalked out. The interesting feature of our wheelchair is basically the end effector or the grippers. So this no wheelchair, even in abroad, they are having this thing. So abroad wheelchairs are basically the motion technology. That is true, and they can have autonomous motion and to the extent possible, but they don't have any feeding systems. So this feeding system is a unique feature that our wheelchair is having. And in that case, I have actually made 7 designs of the grippers that we can use in that in a modular basis. That is, whenever the customer needs a particular design, we can offer the same thing to that same thing to him. So that is the idea. All analysis etc. is going on, and after fitting the hand, so-called hand, can be soft finger, can be a kind of a semi-compliant fingers. So those will be actually fitted with the system. So 2 3 institutes in India are actually taking part in this big activity for the from the research point of view, and apart from the company. So we have started with some basic conceptualization, and then hopefully the things will be ready in couple of months from now. And these are the 2 designs basically has surfaced out, and both the designs have got some advantage, some disadvantage, but it's very unique to see the things at our most Indianized condition kind of thing, so that we can have not only the patient sitting there, we can have patient sleeping also, or in a relaxed posture also. So that's the reason we have made the seat in a much larger way. And also it will be serving a purpose that since the mobile robot has to carry a heavy load, basically a person weighs from 80 to 90 kg, that has to taken by the mobile robot. So that's also a beauty, sorry, that also a necessity for making the platform wider, and that wider platform is being used for relaxing the patient. So these are the some of the particular niche ideation of our design, and hopefully those will be actually taken care of by the company who is actually making the prototype ready for that. And the last one and the of my sojourn is basically a Ganpati robot. This is actually Lord Ganesha. As you know, in Maharashtra and Gujarat, we celebrate Ganesh Chaturthi in a much fanfare, just like our Durga Puja in Bengal. So there was some interesting request came to me, and myself and my colleague from IIT Gandhinagar, we started thinking that can we make a Lord Ganesha kind of a robot. So it was initially through a very interesting and light chat between us, and then we got some good number of scholars uh, whom we actually involved them, and they have given a very good product in the just 1 month or 2 months back. So I thought of including these slides in this presentation also. So this is basically a biomimetic elephant robot with tendon-driven continuum trunk with flapping ears. Essentially, a lot of technologies are there, etc. So one is, of course, the basic body of the elephant robot, which is in the bionic form, and tendon-driven continuum trunk, which itself is a very good robotic technology. That continuum robot is another area where a lot of research is going on, and it can be a very good addition to social expressive robots also. And flapping ears. So flapping ears is also a good mechanism actually. So these are the ideas for us, and the students immediately like the idea, and this is the first iterations of that particular design, that how we started the design. The Ganpati, the Lord Ganesha will be in a sitting posture actually, and that is the reason we have made the CAD models with that kind of thing, very initial CAD model, and I will show some of the interim progress and final things. And this continuum trunk is essentially the idea where a lot of theory and mathematics went. So I am not detailing for that, but this is the way the 3D printed things happen, and with our calculation, etc. Similarly, the flapping ear mechanism is another interesting mechanism by as such, that how the ears will flap. So the Lord Ganesha's 2 big ears, so they will flap. Okay, so depending upon the uh, sequence and this thing. So it took us some time to conceptualize the thing, that what will be the angle of this flapping and all. So after some basic calculations we could arrive at the things. And after fitting the trunk, the things will look like this. And all the, as you can see, the big fat belly of Lord Ganesha, again the same technology of all SERs. So that will actually house the electronics and the components and all. So this particular part is almost like a common thing for all SERs. And finally, this is my Lord Ganesha, our Lord Ganesha. So this is the final fabricated portion, fabricated prototype of the things. And you can see the flapping ears and the continuum trunk, the belly, and at the bottom, all the motors and things are there. The control systems are basically inside the belly to some extent, not fully, but we have got a sort of a platform, I can say. And this has been just made in a transparent form to show we have just applied for patent actually. I mean, in fact, just it will be going. And so this is the motor connections and all for all the system that is at the base. So this is basically the our tribute to socially expressive robots in most Indianized context with a kind of a uh, regards to Lord Ganesha. And with that, I am ending my talk with a namaskar to Lord Ganesha and to all of you that we can do the much good research in socially expressive robotic system to make it more intelligent. Intelligence is anyway there, but let it be a implementable AI where actually we can see the performance in a good way, and it will be useful for the society, for the Indian community as such. Thank you very much.
Thank you very much, sir. One long session you have taken, sir.
Yeah, yeah, exactly.
So many video and the presentation. Fantastic
Yeah,
work, sir. Huh?
yeah. Thank you very much. I
Sir,
am just,
so much work you have done, sir.
just a
Uh,
minute. I am just, I think close down the session link. I am just joining it. 1 minute.
okay, okay,
I mean, accidentally
okay.
I closed down the browser.
Okay, sir, no issue.
Yeah, yeah. Yeah.
Yes,
So,
sir. Yeah.
yeah. So I think I have, it is little late in the night now,
Yes,
and
sir, yes,
if
sir.
you have any queries, you can put up, and that will be, I will be happy to answer. And
I think many are hungry, sir. Today is a working day and the second
yes,
session long.
yeah, yeah. Second session, definitely it
Many
is
are
late in the
many are
hours.
faculty members, no? So some are really.
Okay, okay. No, no issue, no issue. I mean, this happens. So anyway, then thank you very much for
Thank
your
you very much.
time and patience. And
Thank you, sir.
thank you so much.
Sir,
Thank you very much.
excellently emphasize everything. So I think nobody has some doubt on that things. Sir, you have done a lot of work on that field, and I hope in future also you will do many things also in this field.
Yes, thank you, Shumantro,
Thank
and
you,
thank
sir.
you all faculty, Rahul and Dr. Nayak and Madam, or whoever other faculties have joined and from other institute also. This is a good journey or great journey and very passionate journey for myself as such, and also the team. And I am also fortunate to get many good researchers, good colleagues, and from different institutes also, not only from my own organization but institutes also. So with that I could come to that, and I feel that something for the country, doing something for the country is my duty. I am a government servant. Sometimes I jovially tell, so let me do something for the country to the extent in my capacity. So thank you very much, and
Thank
Thank
you
you,
very much.
sir. Good night.
Bye.
good night.
Good night, sir. Bye, sir.
Thanks.
Bye.
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 Bye, bye, bye.